Check, mic check. Check, mic check. Check, mic check. All right. Welcome in, Sean. And first one in, guys. Welcome into the chat. Welcome into another live stream. Today is Monday, October 13th, 2025. Guys, I'm going to wait a few minutes for people to chime in. Let's do a custom poll today. I'm going to customize this. Let's do 40 minutes on the clock today for this one here. LB says physics. Guys, we're going to do a poll. 40 minutes on the clock today. I think we're going to try something a little bit different. I'm going to wait just a few more. I'm just going to wait a few minutes for people to chime into the chat. We're still early. We're still just getting in. LB, thank you for your first vote. Physics. Okay. Guys, how's everyone doing? Welcome into the chat. My name is Dr. Andrew Sanchez, PhD in chemical engineering. If you're new here, welcome in. Comment the word new so I know that you're new and we can welcome you in here. Focus. I actually did not work out yet. I went straight to work today. I'm assuming you saw my system today. And I missed my workout. So right after the live stream, I'm going to DM some folk and go to the gym. What about you, my friends? How's everyone doing? We are just getting started today for another live stream. I'm going to wait a few minutes before we get started. As you can see, we got 40 minutes on the clock. What should we focus on today? We got one vote for physics. Jackson, welcome in. Good to see you. How are you doing, buddy? What time am I going to the gym? At approximately 8 p.m. my time. Guys, we got 40 minutes on the clock today. Make sure everyone votes. We got lots of material to talk about today. I'm going to try to go on for about 2.5 hours today because I feel relatively high energy. Guys, have you guys heard of NeuroGum? I've been trying NeuroGum and that's been helping my focus tremendously. It has about 40 milligrams of caffeine and 60 milligrams of L-theanine, and L-theanine gives me lots of focused relaxation. I feel very relaxed. My stress is low. Brandon says A. Alf says calculus. Guys, make sure you vote in the poll though. Make sure you tap the top left to vote in the poll. How's everyone doing? Is everyone feeling good still with this semester, or are you feeling cooked, stressed? I don't want you guys to feel stressed. That's why I'm out here to answer your guys' questions here. Okay, we're going to go ahead and go through. Oh, we got 2 votes for physics today. We got 2 votes for physics and 1 for calculus. None for chem. We got none for chem. Young Cook, good to see you. Neva says calc. Guys, make sure if you comment the letter D, make sure you vote in the actual poll. George says physical chem. That's new. General biology. Okay, guys, if you comment, make sure you actually tap the poll so I can actually see. We got 3 votes for physics and 1 for calc. None for chem today. This is interesting. I thought we were going to be doing only chem. The poll should be on the top left of your screen, my friends. The poll's on the top left. So click on the top left that says poll. Ooh, George says mass transport. Okay. There we go. We got some Gen Chem, 1 for OChem, 3 for physics. Wow, physics is winning today, guys. I'm going to do the poll. I'm going to leave it open and see how this is going to go through. I'm going to wait a couple more minutes before I get started, and I'm going to leave it open. So whichever one wins will be what we focus on. Neva says calc. Interesting. This is different than last week. I thought, because last week OChem was cooking. But this time there's only 1 for OChem. Twin. User isolate. Shaw says OChem. Guys, how's everyone doing this semester? Are you getting cooked or are you still cooking? How's everyone doing? What are you guys taking? What is going on? When's your guys' midterms and exams? How are we feeling? Let's do like a check-in. Are we feeling still okay? Remember to breathe. Remember that it's just a game. Guys, school is literally just a game. And it's not the end of the world if you're getting cooked. Shaw says cooked AF for OChem, right? Shaz, make sure you vote for OChem, bro, if you want to do OChem. Neva, okay, by far. Was getting cooked, but I made a comeback. W Jada. Gen Chem is not doing so good. Why do we have to take OChem? For chemical engineers, we need to take organic chemistry because we need to be really good at chemical engineering, chemical processing for organic chemistry. Stud dying. User is stud dying. Studying, more like stud dying. Dienophile, more like I'm dying file. When you take OChem or Go 2, you're gonna learn about dienophiles. You're gonna be like, I'm hashtag dying. Cooking, taking AP Chem, Physics, Calc AB, World and Music Theory. Oh my gosh, Dylan, W, are you alive? That's a lot. AP Chem, Physics, Calc AB, World History, and Music Theory. That sounds tough, Dylan. W, Dylan. That sounds tough, but sounds really fun though. Professor is making synthesis problems for SN2, E2, and I'm so confused to do it opposite. Shaz, did you join the Discord, bro? Because I think I dropped my SN2, E1, E2 stuff in the Discord. Guys, we got 5 votes for physics, so I think I'm gonna change this up. Because here was my tentative plan, and I thought OChem was gonna win, so let's change this plan. I think I'm gonna start with AP Chem and Gen Chem today because I want to be there for my high school chem friends that are struggling with Gen Chem, and then at 6 o'clock, whichever one's the winner, which it could be physics. I put OChem here, but it seems like physics is actually cooking today, which is fine by me because, guys, I love physics. I'm going to wait 2 more minutes before we get started, and I'm going to go ahead and start with general chemistry today. I just want to know what topics should we do in Gen Chem. Stoichiometry, reactions, or electronic configuration, or molecular orbital theory, or resonance, or electronic configuration, or electronic geometry, or molecular geometry, or via CPR. We're going to start with Gen Chemistry today, guys. I hope that's cool with everyone because I want to be there for anyone that is getting cooked by Gen Chem because I was the one that was getting cooked, and so I know what it's like. Okay, so I'm going to wait for 2 minutes on the clock, but keep voting, okay? Keep voting because at 6 o'clock is going to be whoever's the winner for the poll. Whoever's the winner for the poll will be whatever we do at 6 o'clock PST or 9 o'clock EST. And then at 7 o'clock PM PST, that's 10 o'clock EST, will be an AMA. So make sure you drop your questions in the Discord. Thank you, Jada, for subbing. User says electronic configuration. You have several questions. So, guys, I'm going to wait 2 more minutes and then we'll get started. I do want to let you know that I have my TikTok. Okay, you can go to engineeringminds.co. So let's go to engineeringminds.co so you can see all the resources that will help you guys out. See all the resources that are going to help you guys out. Okay, number 1 is Khan Academy though. Don't even sleep on Khan Academy. Okay, so but my website though, if you guys like my website, then go to engineeringminds.co. And then boom, right there is going to be, oh, that was the old website. Hold on a second. There we go. Okay, boom. So engineeringminds.co, what you're going to find here is number 1, tutoring. So if you need tutoring, you can book your free session here. Abby, thank you for the follow. Brandon, thank you for the follow. You can join, you can see the tutoring plans here. You can join the Discord, which is free. So click this link that says Discord. And this is where I drop all the notes for all the sessions. TikTok Q&A here as well. And then last but not least, explore resources. So make sure you click on this button that says explore resources. If you're taking Gen Chem, you're going to scroll down to Gen Chem. Right now it's under maintenance, so don't click it yet. It's under maintenance, but just wait a day and it'll come back probably sooner. And it's going to come back, and then there's going to be all these resources for chemistry, physics, math, etc. Last but not least, you can click on these links that go to my YouTube channel as well. And so on my YouTube channel, they're going to show you, you're going to see all my videos, which also is under maintenance as well. But that will be up later today or tomorrow. All right, guys. So I'm going to bring up the poll one more time, and I'm going to bring up the schedule for today. I'm going to go on for about 2.5 hours today. Right now it's 5 o'clock my time. And and I'm going to go for about 2.5 hours. So physics is cooking today. So I think this is what we're going to do. 5 o'clock right now, we're going to do AP Chem and Gen Chem. And then 6 o'clock, whatever is the winner from the end of the poll, that's what we're going to do at 6 o'clock EST, 9 o'clock EST. And then 7 o'clock, whoever's still here, we're going to do the AMA. So that's going to be answering your Q&A questions for the rest of the day. All right, and we'll get started right now. So anyone that's just joining into the chat, my name is Dr. Andrew Sanchez, PhD in Chemical Engineering. If you're new here, comment the word new. I want to let you know that I offer private tutoring services for various STEM subjects, including math, chemistry, and physics. You can sign up for a free consultation call at the link in my bio. I can help you out with AP Chem, General Chem, Organic Chem, Physics, Math. And today's topic is going to be AP Chem. Stay tuned for more videos and make sure you hit that follow so you never miss another live. Join the Discord for free. Okay, so today's topic is going to be AP Chem and Gen Chem for the first hour. And then, like I said, we're going to go ahead and do that at 6 o'clock, whoever's win. Okay. So, what's up? So I'm going to do another quick poll. So, guys, drop your Gen Chem questions. So someone said electronic configuration. So let's start with electronic configuration here. And you need a periodic table. So make sure you go download a periodic table. Okay. And then we're going to go ahead and download a periodic table. So the number one most important thing you're going to need in Gen Chem is a periodic table, right? So the first topic is going to be electronic configuration. So I'm just going to download this, save, and then I'm going to show you how to read the periodic table. All right. So I'm going to get my periodic table, which didn't seem to download. Okay. So I'm going to get my periodic table, and then I'm going to save this, save 2 photos. I'm taking requests later, yes, but make sure you drop your questions now or join the Discord so you can see what is here. Here we go. So here's our periodic table, and again, the first topic we're going to do is electronic configuration. Isoelectronic. All right, perfect. So we're going to talk about electronic configuration first. So, and then by the way, I have a video that goes over this on my YouTube channel. So just sub to my YouTube channel, link in the description. All right. So we have our periodic table, and let's go to element number 1. Okay, let's go to element number 1. So this is going to be hydrogen here. Okay, is element number 1 here. And then this is going to be element number 1. And so it's going to be column number 1. So this is the first column. And what I want you to do is, let's erase this. I don't need this. This is the first column. I'm going to put a box around it. I'm going to put a number 1 for column 1. Okay. And then what I'm going to do is I'm going to go to column number 2 and put a box around column number 2. Okay. So guys, do me one more quick favor before we fully get into it. If you're ready to lock in for Gen Chem or AP Chem, go ahead and comment a lock emoji if this is a good topic. We're going to do AP Chem and Gen Chem. If you're ready to lock in, comment a lock emoji because I might not read the chat for a bit. I'm going to lock in, guys. So comment a lock emoji, and then we're about to do these Gen Chem electronic configurations. Okay, so Rest says I'm in Calc BC. User, thank you for the lock in. Guys, if anyone's taking AP Chem right now or general chemistry, I highly encourage you, get out a sheet of paper and do this along with me. It's going to make way more sense. If you're not in Gen Chem, it's fine. Just hang out, follow along. But if you're in Gen Chem, please get out your notes. All right, so this is column 1, this is column 2. So in column 1, I'm going to put a 1, and so this is going to be 1 valence electron. So for example, hydrogen is in column number 1. I'm going to put an H, and then I'm going to put a dot. So the dot indicates I have 1 valence electron, right? Lithium, column number 1. So lithium, I'm going to put an Li, and then I'm going to put another dot. So lithium has 1 valence electron. Need I say more? Do we see the pattern? Okay. Sodium, column number 1. So I'm going to say sodium, Na, that's 1 valence electron. Okay. Keep it going. Potassium, column number 1, 1 valence electron. All right. So I think you guys get the point. Column number 1 has 1 valence electron. Column number 2, guess how many valence electrons it has? So column number 2 is going to have 2 valence electrons. So Be is going to be 2 valence electrons. One I'm going to put on the side, and then the other one I'm going to put on the other side. So 2 valence electrons. Mg, I'm going to Mg, one on the side, one on the side here. Now, how do I know the charges? We got to do that. How do I know the charges? How do we know what's ionic covalent string bases? What do you mean string bases? Oh, strong bases. Okay, got you. Grade 9. I was thinking of like violins. I was like thinking of like the cello because you said strings. Okay, there you go. Jada says ionic is a metal plus non-metal. Okay. I was thinking of cellos. Okay, so column number 2, put 2 electrons. Okay, guys, if you pay attention for this subject, if you pay attention for this topic, this is going to explain everything simultaneously. I'm going to explain electronic configuration. I'm going to explain bonding. I'm going to explain covalent versus ionic. But before I explain all those questions you guys are asking, make sure you understand, okay, the electrons. So if you're understanding right now, if H has 1 electron and Li has 1 electron, put a thumbs up. Okay, if you understand that beryllium, which lives in the second column, has 2 electrons, put a thumbs up. If you understand that magnesium also lives in the second column, has 2 electrons, if this is making some sense so far, put a thumbs up. Yes, I have a YouTube channel as well. It's the same as my TikTok, link in bio. Thank you, Uromi, thumbs up, good job. Okay, good job, Uromi. Okay, happy face, thumbs up, invisible chats. All right, very good. So you guys are getting this so far, right? And now this is gonna make a lot of sense here. For the metals, we're gonna ignore them. Okay, for the metals, we're gonna ignore them. And again, guys, let me just show my YouTube channel real quick because I did all of this on my YouTube channel. So if you missed any part of this, you can just sub there, and then you can see what I'm talking about here. Okay, so just go to my YouTube channel. It's the same as my TikTok, and then click this video that says valence electrons and Lewis structures. Okay, so this is the same as my TikTok. So, but I'm gonna save you the trouble here. I'm gonna go over basically everything that I mentioned here, electronic configuration and etc. etc. All right, so let's keep it going. Okay, so let's keep it going. So now, okay, so now I'm gonna go to column number 18 here. So I'm going to go to column number 18 and I'm going to basically ignore the transition metals. So the transition metals, there's too many exceptions. We don't need to worry about them right now. We will talk about them, but for now, ignore the transition metals. Okay, so column number 18 is going to be right over here. And so we're going to put, okay, let's start with helium because helium is an exception. So helium, we're going to put 2. Okay, so helium, we're going to put 2 valence electrons, so that's an exception. But for the rest of these, starting from neon, we're going to put 8. And the way you memorize this is column number 18. 18 minus 10 equals 8. Okay, so for 18 minus 10 equals 8, all of these we're going to put 8. Okay, so neon, we're going to draw Ne, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so for argon, that's going to be column number 18, so that's going to be 8 valence electrons. So again, I'm going to do argon is going to be 8 valence electrons. So argon, 1, 2, 3, 4, 5, 6, 7, 8. Notice how I did that. Let me erase that and do it one more time. Notice how I did that. I'm going to do, again, 1, 2, 3, 4, 5, 6, 7, 8. I go top down, side to side, top down, side to side. That's going to be important later. Guys, if you're understanding about noble gases, go ahead and put another thumbs up down in the chat. If you're understanding what I'm saying, that noble gases all have 8 valence electrons except for helium, put a thumbs up if this is making sense so far. Why did you subtract by 10? Because we have neon is the 10th element. Okay, so neon is going to be the 10th element. That is going to be our first noble gas. Okay, Jada, thumbs up. Good job. Okay, homie, welcome in. Guys, we're going over Gen Chem first. Let me bring up the schedule one more time in case you guys have any questions. You can drop those questions in. Let me just bring up the schedule. Let me see if everyone's paying attention here. So Jada, so far I see only 1 thumbs up, guys. Is that making sense so far? Okay, is that making sense so far? So again, with helium, we had 8 valence electrons. 2 valence electrons, neon 8, argon 8. What about krypton, guys? So krypton is going to have how many? How many valence electrons is krypton going to have? Okay, Iromi, thank you, thumbs up. Young Cook says yes. Thank you, good job, good job. So how many is krypton going to have here? Okay, how many valence electrons is krypton going to have? Good job, it's G8, Iromi 8, good job. Okay, you guys are getting this. Okay, you guys are cooking, so very good, very good. So now here's my trick. Okay, here's my trick. For the rest of these, we start with the noble gases, and then we're gonna go left, 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 and then subtract 1. Okay, so in these ones, okay, we're gonna subtract 1. So for this column, these are called the halogens. Okay, everyone try to memorize the column number 17 is gonna be halogens. and then we just subtract 1. So 8 minus 1 is 7. Okay, and then this column, guess what? We subtract again. This is going to be 6. Okay, this column again is going to be 5. And then carbon is going to be 4. Also, Si is included as well. That's going to be 4. And then boron and aluminum are also going to be 3. Okay, so that's how to make chemistry actually low-key easy and low-key fun as well. So as soon as we start with column number 18, then again, this is going to have 8 valence electrons, and then fluorine is going to have 7. Okay, and then nitrogen is going to have 5, and then carbon is going to be 4 and 3 for boron. Guys, if this is making sense, drop a thumbs up. Okay, if this is making sense, drop a thumbs up. We're going to do a quick poll. Okay, we're going to do a quick poll. Jackson says that the resource database is back. Just go to engineeringminds.co. Oh guys, actually I can't do a quick poll because I'm doing the full poll. So I'm going to do a quick poll later. So studying for a chem exam. Good luck, Angel. Jada says Young Cook. Jada, thank you. Young Cook, thumbs up. Thank you. Hybridization, guys, good luck on hybridization. We're going to be kind of talking about that as well. All right, so quick question though. So let's see phosphorus. So guys, if I asked you how many valence electrons does, for example, phosphorus have, how many would you say for phosphorus? Okay, thank you, Jada. Appreciate you. You guys are good students. So how many valence electrons does phosphorus gonna have? Young Cook, cooking. Now we know why you're called Cook, because you're cooking. Rozzy, welcome in. 5. Homie says 5. Jada says 5. Okay, a little confused about the orbital diagrams. That's okay. That's a really hard topic. Orbital diagrams are definitely confusing. Aromi says 5. Good job. Good job. All right, so I think you guys are getting this. So now what's going to happen if we combine these? Okay, so now what's going to happen if we combine these together? So let me move this to the side a little bit, just like that. Okay, so now we're going to combine what we're learning here. And for example, the first thing that we have to do is NaCl. Okay, we're going to do NaCl. And we have to identify if this is ionic or covalent. We have to identify if this is going to be ionic or covalent. So we're going to go to the periodic table, and we're basically going to determine where is NaCl and where are they living on the right hand side. Now here's the rule versus ionic versus covalent. So ionic is going to be a metal plus a non-metal. And how do we know if something's a metal? Okay, we're basically going to make a staircase shape like this. Okay, I want you to make a staircase shape. Go under boron and then go below carbon and silicon, just like that. As a matter of fact, include, let's see, do we want to include silicon? We're going to include this staircase just like these, okay? And we have this staircase shape, okay? And anything to the right of the staircase, okay, anything here, these are all the non-metals. Everything else is a metal, okay? So the way I like to divide it here is the left-hand side is going to be all the metals, and the right-hand side is going to be the non-metals. Okay, so if something is covalent, it's going to be only the non-metals bonded together. If something is ionic, it's only going to be the metals plus the non-metals, right? Okay. Okay, very good. So now NaCl. Now we got to find NaCl. Is that ionic or covalent, guys? Is this NaCl? Is this ionic or covalent? Okay, so we got to find Na and Cl. We got to find them on the periodic table. So Na lives right over here, and then Cl lives right over here, guys. So Na lives on the left, and then Cl lives on the right-hand side. So therefore, the left-hand side is a metal, and then the right-hand side is a non-metal. Okay, let me make this a little bit bigger. I'm not sure what's going on here. There we go. There we go. Okay. There we go. So NaCl, we have left and right. Okay, so there we go. Good job. Okay, good job. So this is going to be a non-metal and a metal. So that's going to be ionic. Now, we got to draw the valence electrons. So we're going to have Na here, which has 1 valence electron here. Why does it have 1? Because, again, it lives on the first column here. So 1 valence electron here is Na. Okay, Teddy Bear, thank you for the follow. Whoops, guys, I was moving that. There we go. So Na is going to have 1 valence electron. And what about Cl, guys? So again, if you missed it, just go to my YouTube channel where I explain this a lot slower. So Cl is going to live in column number 17, which has 7 valence electrons. So I'm going to draw a Cl, which has 1, 2, 3, 4. Okay, so I'm going top down, side to side, and then 5, 6, 7. Okay, and then what do we notice here, guys? So what do we notice here? The octet rule states what? Guys, does anyone know what does the octet rule stand for? What does the octet rule in chemistry tell us? So what does the octet rule in chemistry tell us? Think about like octagon, right? Think about like octagon. Octagon has the word 8. Okay, so very good. All right, so octagon means 8. So basically the octet rule states that we have to have a full valence. Good, period. Good job, Edwina. All right, so that means that this chlorine is basically has 7 valence electrons here, right? We said that chlorine has 7. And so the chlorine really wants to have 8. Hi, period. Do the dots really matter? Yes, the dots are really important, okay? So the chlorine really wants to have 8, and right now has 7. And then the sodium is really far from 8. So sodium is thinking, you know what? I'm feeling nice today. If chlorine really wants 8, I'm going to basically just give him 1. Okay? And chlorine is feeling greedy, okay? Chlorine is basically feeling really greedy. He's thinking, you know what? I don't really care how sodium feels. I'm going to steal that electron. Okay? And then we're going to represent that by a transfer of this electron. Okay, I'm going to basically move this electron over. So sodium is really nice and chlorine is really evil. Okay, so now this is an ionic bond and we formed an ionic bond. Okay, guys, does everyone understand ionic bonds so far? If this is making sense, drop another thumbs up. Okay, if you have any questions, drop a crying emoji so I can know where I made it confusing here. Okay, so chlorine is really mean and stole the electron from sodium. Guys, we're going to do a bunch of examples. Okay, Edwina says yes. Is this really how chemists reasons? Absolutely. Wait till you get to organic chemistry. If you stick around for the organic chemistry lesson, we're going to talk about rheology. Okay, because organic chemistry is basically rheology 101. Okay, guys, is this making sense? Okay, who's ready for another example, guys? Okay, is this making sense? All right, and then we're basically going to, Jada says yes, thank you. Edwina says yes. Good job, guys. So we're going to do another example, and then here's going to be another trick. So I'm going to give you a compound here, and I'm going to say we have Mg. Okay, I'm gonna say we have Mg and Cl2. Okay, so now what do we have in here? Sorry, guys, we're not ready for this next example yet. We're not done yet. So what's going to happen? So sodium lost an electron and chlorine gained an electron. Okay, so we're not done here yet. So sodium lost an electron. And you know what? Sodium feels really happy because it lost an electron. So it became isoelectronic. Let me write a word that someone in the chat commented earlier. Isoelectronic. Okay, to another compound, and then this is going to be isoelectronic to another compound. So if you know this word, let me know what it's isoelectronic to. Okay, so sodium became isoelectronic to one element, and then chlorine became isoelectronic to another element. So let's see what happened. So sodium gave away its electron. Where did sodium live? Let's go back to the periodic table. So sodium lived here, but it gave away an electron. So now we got to go back to the second row, and we see that it became isoelectronic to neon. Okay, Gab, heat capacity. I got you, Gab. Okay, it became isoelectronic to neon. Okay, became isoelectronic to neon. And then chlorine, let's see what chlorine got, because it got an electron. So now it's going to be isoelectronic to argon here. And so the way we're going to represent that is we say NaCl is going to break apart into Na plus and Cl minus. Okay, does everyone see how I did that? We said that sodium lost an electron, so it has a positive charge, and chlorine gained an electron, so it has a negative charge. Okay, guys, if this made sense, drop a thumbs up down below. Can you explain nomenclature? Is that for OChem or Gen Chem? Gab, for heat capacity, stick around. We can do that next. Heat capacity and fusion. Gab, are you in high school or college, my friend? Are you in AP Chem or college chemistry? All right, Iromi, thumbs up. Good job. Ario, thumbs up. Okay, Edwina says thumbs up. Good. Okay, good, guys. So let's do another example. So that's Na plus and Cl minus. And then I forgot to write that Cl was isoelectronic to argon. Okay, why argon? Because it lives right next to that one here. Intro to Gen Chem, first year college. Okay, perfect. So we're going to do a couple more examples for isoelectronic, and then we're going to do we're going to switch gears here to basically heat capacity and fusion. Okay, perfect. So guys, now we have MgCl2. So here's our next example. Okay, so here's our next example. So what we're gonna do is try to predict the product here. We're gonna try to figure out what's on the right hand side here. Okay, is it gonna be a plus charge, a minus charge, or what do we have here? Okay. Okay, and then how do we do that here? So what did I say? The bestie is your periodic table. So we go to our bestie and we see that Mg has 2 valence electrons. So we're gonna put a 2 right next to the Mg. Okay, we're gonna put a 2 right next to the Mg. Okay, and then our Cl is going to be on the right hand side. So we said that it's gonna be a 7. Now, what do we notice for chlorine last time? Okay, so we saw that chlorine gained an extra electron. We're going to put a -1 actually. Why is it -1? Because 7 minus 8 is -1. So remember, I said put a 7 right above this column. 7 minus 8 is -1. Very good. Okay, so someone said Mg2 plus and then 2 Cl minus. Good job. Okay, so Mg2 plus 2 Cl minus. Okay, does everyone understand how I did that here? I basically looked on the periodic table and we said we have minus here. Now this 2 is because we have a 2 right here. So this 2 I'm highlighting in orange. That's why this 2 becomes now the coefficient here. And guys, here's a really good trick, okay? Here's a really good trick. This is called, I like to call it crisscross applesauce. So remember in preschool when we learned crisscross applesauce? Let's say we wanted to go backwards. So we know that we have Mg2 plus and we have Cl minus. We want to know what compound forms. We go crisscross. That -1 just becomes a regular one. And that 2 goes over here. So notice that the 2 becomes on the Cl here. Okay, so that we have MgCl2. So that's called the crisscross applesauce method. I love doing this method because this makes it way more easy to visualize here. Okay, if you make chem easy and you can visualize what's going on, it actually makes chem low-key fun. Young Cook says, I'm confused. I looked away for a few seconds. Oh no. Okay, so Young Cook, so we basically just did our second example. So make sure you understand the first example, bro, before you move on to example 2. So example 1 was NaCl, and then we said that we had a happy ion for sodium and then a mean ion for chloride, okay? Okay, because chloride was basically stealing sodium's electron, okay? Chloride was stealing that electron. All right, what's the molecular mass of the compound? Great question. So how do we calculate molecular mass, guys? So if we want to calculate molecular mass, we have to basically take the molecular mass of Mg. That's a really great question. Let's try that out. Okay, so let's get the molecular mass of MgCl2. So we got to take Mg. We're going to look on the periodic table. And then we got to look for Mg. Okay, so Mg lives right over here. It's 24.305. Okay, 24.305, and then we got to take 2 of the Cl's. Why do we multiply by 2? Because we have 2 of the Cl's here. So I'm going to take 2 of the Cl's here and then multiply that as well. Okay, and do that as well. Okay, and then here we go, guys. So then I go to Cl and I see that's 35.45. So I'm going to take 2 times 35.45. So someone please calculate. Someone get out your calculators and please calculate what that is, and that's going to be the molecular mass of that compound. So someone please calculate 24.305 plus 2 times 35.45. Guys, welcome into the chat. Anyone that's just joining in, we're doing some general chemistry today. Guys, I want to do a quick poll. I think I'm going to cancel this poll. I think physics 1. Let's see how's the poll today. I was asking the question, what should we focus on today? And I see a lot for physics, but I wanted to start out with Gen Chem because I know Gen Chem is really hard. So we got physics is going to win. So here's my schedule for today. We're doing AP Chem and General Chem reviews. So drop your questions for AP Chem and General Chem. Guys, I'm going to do another poll. I want to see if this is making sense, and I want to see if we want to do... Okay, I got to end this poll. Okay, Arya says 70.9. Thank you, Arya. So we're going to do physics in about 25 minutes. So we're going to do Gen Chem for about 25 more minutes, and then we're going to switch to physics, Kaylin. So, guys, I'm going to do a new poll here, and then I'm going to do a quick poll this time. So physics cooked today. That's really interesting. Usually Gen Chem cooks, but physics cooked today. Okay, and then I'm going to do a new question. So I'm going to do a new question here. So we're still doing Gen Chem, and then I got one question for electronic configuration. So that was electronic configuration. And I'm going to do a new poll. So we're gonna do, what topic should we do next? What topic should we do next? And let me get this poll ready here. Do next. And if you want to do stoichiometry, like, you know, calculating, limiting reagents, things like that, you're gonna vote for a happy face. You're gonna vote for a happy face. And then if you want to do thermodynamics, so someone said like heat capacity, okay, you're gonna vote for a crying emoji. Okay, so stoichiometry is like limiting reagents, balancing reactions, okay, things like that. And then thermodynamics is like heat capacity, temperature, energy, and things like that. Okay, and if you want to do none of that, then just comment none, and then we're gonna do electronic configuration. So I'm gonna only put 60 seconds on the clock. Okay, bond energy and enthalpy, vote for thermo. So if you want to do energy, vote for thermo. Energy, vote for thermo. Okay. Okay, 60 seconds on the clock, starting now. So Young Cook, let me answer your question here. So why did we do the crisscross method, bro? Because we basically had the crisscross method is we go to magnesium, and we saw that magnesium lives in the second column, right? Let's go back to magnesium real quick. Okay, so magnesium, bro, lives right here. So magnesium is right here. I said that's the second column. So anything that's the second column, put a 2. So that's going to be a +2. Okay, so +2, you're going to put a +2, but chloride has a -1. Why does it have -1? Because I said put a 7 right here, and we're going to do 7 minus 8. Okay, 7 minus 8 is a -1. So you have to subtract it from 8. So 7 minus 8 is -1. So now with magnesium, you do Mg2 plus, okay, Mg2 plus, and then Cl minus, you do the crisscross method. So one more time, let's see how the crisscross method works one more time. Guys, make sure you vote on the clock. Make sure you vote in the poll. We got 60 seconds. We got just a few seconds left. Okay, we got an even, guys, we got an even vote. We got 2 and 2. Okay, we got 2 and 2. We got 2 for thermo, and we got 2 for stoichiometry. So maybe that's going to be both. We got to just do both. So I'm going to do stoichiometry first. I'm going to do stoichiometry first, and then we're going to do thermo next. Okay, so I'm just going to close this, and then we're going to do stoichiometry. So I said MgCl minus, and then once again, the crisscross method, once again, is going to be bringing that 2 here. So the Cl is going to have a 2 right here. So I'm going to put a Cl2, and then this is a minus. This is basically a 1. Okay, just take the absolute value of -1, you just get 1. So this minus I'm going to bring down here. So this 2 goes over here. I'm going to put Cl2, and this is just Mg1. So that's how I got MgCl2. Okay. All right, guys. So we got 2 votes. We got equal votes for stoichiometry, and then equal votes for energy diagrams, energy thermo, and things like that. Okay. Is that also can be used for making the empirical formula? Exactly. Okay, so if they ask you empirical formula, make sure you use the crisscross method, guys. Okay, if they ask you the empirical formula, we're going to do the crisscross method. Okay, guys, I'm going to move on to another topic because we have a lot to cover today. So I'm going to do stoichiometry next, and then I have a question. Okay, I have a question for you guys. Do we want to do stoichiometry first and then energy next? Okay, and so we're gonna do stoichiometry first and energy next. But my question is, do we want to do stoichiometry, make it easy? So explain stoichiometry, make it easy, or do you want to do stoichiometry like a hard version? Okay, like like let me know if I want to explain it like the easy way or the hard way. And like by hard way, I mean we're just gonna do examples. So like, should I explain it from scratch and like we're gonna go easy from scratch, or like just like, okay, I get stoichiometry, I just want to do some harder problems. Okay. I wanted to do energy. Lizzie says hard. Okay, Lizzie says hard. Loki wanted to do energy. Okay. Iroma says easy. I'm seeing more for easy, guys. Okay. I'm seeing more for easy. Okay. So, okay, we're gonna do stoichiometry the easy way. Okay, we're gonna do stoichiometry the easy way. But again, if you want to do the hard way, again, I already have tons of examples on my TikTok and website. Okay, link in bio. So everyone says easy. CS says Easter. All right, perfect. So we're gonna explain stoichiometry the easy way. Okay, guys. So first things first, I need to make a recipe. So someone give me an example of a product that we can make. such as a food, such as a recipe, such as a product that I can make from scratch, and I need only two. I need two reagents. I need two things to build that product. So what is going to be that product here? So it's going to be like a cake. What should we make today, guys? Okay, Young Cook says cookies. So let's try cookies. So what's going to be the recipe, guys, for cookies? And not only the recipe, but I also need how many of each reagent here? How many of each ingredient? What are the ingredients for cookies? Lizzie says grilled cheese, but grilled cheese is not a product. That's more of like an ingredient. I need like a product like cookies. So if we're gonna make cookies, guys, I think that's a good one. If we're gonna make cookies, what is the ingredients for cookies? All right, eggs and flour. That's a perfect. Okay, that's a really good, perfect example here. So I'm gonna use eggs and flour. Okay, guys, this is called stoichiometry. Okay, this is actually chemistry. Okay, so I'm gonna use eggs and flour. How many eggs and how many flour do I need, and how many batches of cookies are we gonna make? Okay, so someone make up some numbers here. How many eggs and how many doses of flour are we gonna need, and then how many cookies are we gonna make? Okay, so for example, is it gonna be like 2 eggs plus 1 flour equals 3 cookies? All right, so Sully says 300 eggs and 500 grams of flour. So 500 grams of flour is correct, but we're gonna keep it simple. So let's just say 2 eggs, and then give me like a dose of flour. Let's change this word to like one cup. Like how many cups of flour, just to keep it simple, okay? Because people voted for easy today, so we're gonna keep it easy, and then next time we're gonna do it harder with grams. So this time we're gonna do no grams, and we're gonna do only just like keep it simple, okay? Young Kick says 127 cookies. Can we keep it easier? Can we make like 2 eggs? I feel like that's not accurate though. 2 eggs is not gonna make 127 cookies. So maybe like let's say, okay, let's do something like this. 2 eggs plus 3 cups of flour. Let's say that makes 10 cookies, right? Let's say that makes 10 cookies. Okay? So we have 2 eggs plus 3 cups of flour. That's gonna make, okay, so M says 5. Okay, that makes sense. That makes sense. Okay, let's make 5 cookies. Okay. Homie says 16. Maybe 16. All right. I like. Well, what's the average of 5 and 16? Let's say, let's just go with like the 16 here, just to make it fun. Okay. All right. Just to make it fun. Well, that's kind of a lot. So let's just go with like a nice clean number. I'm gonna go with 10, guys. Okay. I'm gonna go with 10 cookies. Okay. So here's our recipe, right? We have 2 eggs plus 3 cups of flour makes 10 cookies, right? So I'm going to say 2 eggs plus 3 cups of flour makes 10 cookies. So here's our recipe. And then what we're going to say is going to be the product. Noah, I see your request, bro. Do you have a question? Okay, do you have a question? And then if so, what's your question? And then I'll accept your request. So if I have 2 eggs and 3 cups of flour, this is our recipe, right? So our recipe is a reaction. All right, so let's say I go to the store and then I buy, like, let's say I'm gonna buy, all right, 24 eggs. All right, I buy 2 dozen eggs, and then I buy okay, and then I buy, okay, let's keep it simple. I buy, let's just start with 2 eggs, okay, and let's go with 4 eggs and 5 cups of flour, okay? 5 cups of flour. Okay, so let's say I go to the store, I buy 4 eggs and 5 cups of flour. Okay, so how many cookies am I gonna make? How many cookies am I going to make if I have 4 eggs and 5 cups of flour, guys? Okay, so we're learning about stoichiometry, we're learning about limiting reagents. So guys, if I have 4 eggs and 5 cups of flour, how many cookies am I going to make here, right? How many cookies am I going to make? Okay, we basically need to do stoichiometry here. We're basically going to do stoichiometry. So Z Amazing says at least 10, right? At least 10, right, guys? So if for every 2 eggs and 3 cups of flour, I make 10 cookies. So let's try that out. So I have 2 eggs, and then I have 3 cups of flour, right? This is going to give me a total of 10 cookies. And then I still have 2 legs left over here. So I have 2 eggs because 4 minus 2 is 2. And then I'm still going to have 2 cups of flour left over. 2 cups of flour left over. So someone said at least 10. That's correct. So with 10, okay, with 10, with 10 cookies, I'm gonna have a little bit more here. And so which one's gonna be limiting? Which one's gonna be limiting here, guys? Which one are we gonna run out first? Are we gonna run out of eggs first, or are we gonna run out of flour first? Okay, are we gonna run out of eggs first, or are we gonna run out of flour? So someone says at least 10, someone says almost 20. How do we get that exact number? Good job. Soli says flour. Okay, Z Amazing says flour. Young Cook, we're gonna run out of eggs first because we have only 5 cups of flour here, and then we already used 3 cups here. So here's how we're gonna do the stoichiometry here. Okay, here's how we're gonna do the stoichiometry. You need to follow my step-by-step process. This is how to make chem actually low-key fun. Okay, as soon as you can make chem low-key fun, you're gonna start seeing so much results here. Okay, so I'm gonna start with what I know. So here's how to do stoichiometry. Step 1, start with what you know. Start with what you know. Okay, so what do I start with? What you have. So what do I have here? What do I have? I'm gonna start with 4 eggs, and then I'm gonna do the conversion factor here. So I'm gonna cancel out, right? I have 2 eggs for every 10 cookies. So I'm gonna do 2 eggs here for every 10 cookies. Does everyone understand how I got the 2 and the 10? Does everyone understand why I put 2 eggs over here and the 10 up on top here? If you're understanding where I got the 2 and the 10, go ahead and put a thumbs up down in the chat, okay? Okay, if you're understanding where I'm getting that, Toad says this makes so much sense, okay? If you're understanding where I got the 2 and the 10 from, go ahead and comment a thumbs up emoji, okay? So I'm gonna basically cancel out this 2 from this 4, and then 2 times 10 is 20. So with 4 eggs, I'm gonna make 20 cookies, okay? I'm gonna make 20 cookies, but then I'm going to basically run out of flour. So now I'm gonna check flour here, okay? And then I'm gonna do flour. So again, I cancel out my 2 eggs for the ratio in the recipe here, and then I'm gonna do that, okay? So step 1 is start with what you have. So now I'm gonna do flour. I have 5 cups of flour here. Okay, so I have 5 cups of flour. Okay, and then what's my recipe here this time, guys? What am I gonna put over here for my recipe? So what does my recipe call for between flour and cookies? So last time I put 2 eggs to 10 cookies, but this time what do I gotta put down here, guys? What am I gonna put over here on this fraction if I wanna make cookies with 5 cups of flour? Okay, so we're not gonna put eggs this time, we're gonna put flour here. Okay, good guess, Kuro, good job, Kuro. Okay, we need to put 3 cups of flour for our recipe. So I'm going to put 3 cups of flour for a recipe, and then we're going to make 10 cookies. Okay, we're going to make 10 cookies for every 3 cups of flour. So 5 times 10 divided by 3, that's 50 divided by 3, whatever number that is, that's how many cookies we made. Okay, so this is going to be like 20 something cookies here. Guys, was I wrong? Did I say that eggs was limiting? I think let's see. What's 50 divided by 3, guys? Let's just do what's 50 divided by 3. So 50, okay, divided by 3 is 16 cookies. So we made about 16 cookies with this many flours. So 16.67 cookies. Okay, so which one did we have more of? Which one did we have more of in theory? Which one was in excess and which one was limiting? Which one was excess? Which one is limiting? Which one was in excess and which one was limiting? What was that all? It was so easy. What do you mean by that, bro? Which one is excess? Which one is limiting? Okay. So if we made with 5 cups of flour, we ran out of flour, right? If we made 5 cups of flour, then we made 16 cookies. Okay. So let's do a vote. Okay, let's do a vote. So if you think that, I'm gonna bring down this example here. Okay, if you think that which one was limiting, let's do this vote here. So in this example, which one is limiting here? So which one is the limiting reagent here? So which one was limiting? Which one was limiting? Okay, so if you think that cookies were limiting, you're gonna vote for a happy face. And then if you think that the flour was limiting, you're gonna vote for crying emoji. So you got about 15-20 more seconds to think about it while I make the poll. Okay, Oh, it makes sense now. Okay, it makes sense now. Good, good. Okay, so here's our example. We have 2 eggs. Okay, you got 10 more seconds to think about it. If you think that cookies were limiting, you're going to vote for happy face. Hold on, guys. I got to pull up the poll. Okay, give me 5 more seconds. 5 more seconds to think about it. If you think that cookies were limiting, you're going to vote for happy face. If you think that flour is limiting, vote for crying. Okay, all right, 60 seconds on the clock. So we got 50 seconds left. Okay, so which one was limiting? We had 4 eggs. Okay, we had 4 eggs and 5 cups of flour. We had 4 eggs and 5 cups of flour. So which one do you think was limiting? Okay, good job. Okay, good jobs. SUC, Fernando, Iromi, good job. Good job, good job. E, good job, period. Okay, we got 5 votes for flour, right? We got 5 votes for flour. So whoever said flour, why did you pick flour was limiting? Whoever said flour was limiting, why did you pick flour was limiting? Okay. All right, guys. So we got 10 more seconds. Fernando says because it is. Because it is. Guys, if you don't know it and if you don't know, just guess. That's totally fine. Exactly, right? Young Cook says the amount of is cookies are less than eggs, right? Exactly, because we had 16 cookies formed from 5 cups of flour compared to 20 cookies. Good job, everyone. So if you got that right, put a thumbs up down in the chat, put a party emoji, put a ooh emoji. Okay, and so good job. If you said 16 cookies, this one was limiting here. Okay, this one was limiting, right? Because we said that was going to be basically the one that runs out, that makes less cookies overall in that batch here. And therefore, the eggs were in excess. So how many eggs are we going to have remaining now? How many eggs are we going to have remaining? Well, now we need to back calculate. Charlie, what's good? Now we need to back calculate how many eggs we have in excess here with our 20 cookies. Okay, this is the overall process for stoichiometry, guys. Is this making sense? Is this making sense? If this is making sense, which one? If this is making sense, drop a thumbs up. Okay, if this is actually helping. And if this is still not helping, if you're still confused about stoichiometry, drop a crying emoji. Oh, Charlie, I forgot to respond to you. I was referring to the Discord, bro. Did you make it into the Discord? Okay, Huel Jackson says, okay, that's what I was talking about. Okay, energy and then heat. Okay, guys, so I'm seeing some thumbs up, so I'm thinking this is making sense. So, guys, I'm going to do another poll. Okay, I'm going to do another poll here. So, should we do the same topic for stoichiometry or should we do another topic? Okay, guys, should we do another topic, another example for stoichiometry with actual elements and compounds, or should we just move on to a different topic? This is making sense. So, you guys got about 5 more seconds. Okay, so we got 60 seconds on the clock starting right about now. There we go, guys. So 60 seconds on the clock. So if you want to do the same topic, which is stoichiometry, which is our reagents and calculations, but a harder example next with actual elements and compounds, make sure you vote for the happy face emoji. If you want to move on to thermo and energy diagrams, okay, then vote for a crying emoji. Okay, I'm seeing a lot more examples for happy face, so you guys want to do actual examples here. Okay. You guys want to do actual examples. Okay, perfect. Now, everyone's voting for the actual examples, so we're gonna do that. But my question for you guys now is, do you want to do one of my problems or one of your own problems? If you have your own questions about Stoic, make sure you upload it on the Discord. I'll be back. Okay, give us a good example. Okay, guys, so I'm going to give you guys one that's not too bad, but not too easy either. So I'm going to do a harder example. Okay, I got you, twins. I got you. So let's say we do this example here. All right, and here's going to be our reaction here. So we're going to do a medium level one. So nothing too crazy, because last time I did a hard one and it took like 30 minutes. It was too hard. That was from my Gen Chem book. That was a college level. So I'm gonna do a medium level one. So first things first, I'm gonna give you a reaction here, okay? But if you're still confused, don't even worry about it. It's gonna be basically the same as the cookies. Okay? So first things first, we gotta let you balance this, okay? So before we even start, the first step is to balance it. I like to call this step 0. So someone please balance this. Okay, someone please balance this down in the chat. How do we balance this, guys? Are you guys good at balancing reactions? If not, let me know. Okay, and then I'm going to tell you what's given is going to be 96.1 grams of propane. Okay, so we have 96 grams of C3H8, and then it's going to say, what do we want? Okay, and it's going to say what mass of oxygen will react. What mass of oxygen will react? And then I'm just going to make this up. I'm going to say, let's say we have okay, let's say we have 400 grams of oxygen. And then what we want is to calculate the grams of CO2. Okay, guys? So this one's going to be significantly harder. Okay? So this one's going to be significantly harder. Thank you, Sully. Happy. Unfortunately, can't do general relativity, Sahil. Unfortunately, that's a little bit out of my scope, guys. Okay, so here's the problem, guys. Here we have this compound here. So we have this reaction here. C3H8 plus O2 goes to CO2 plus H2O. So how do we balance this? Okay, how do we balance this reaction? Well, I have C3 on the left, and then I have C on the right. So what I'm going to do is I'm going to put a 3 right over here so I can balance my carbon, okay? So the first things first, I'm going to balance my carbon. Okay, and then I'm going to balance out my H2O. Substitution and elimination for OChem. I got you, twin. Okay, and then for H2O is going to be very good. Okay, so very good. Three in front of the C. What about for my 8H here? So I have 8 H's on the left, and then I have 4 on the right, guys, right? So I have 4 on the right here. Okay, very good. And then the last one I have to balance is I have a total of, okay, 2 times 3 is 6, plus 4 is 10. So I need 10 on the left, and then I'm going to multiply this by 5 here. So 5 times 2 is 10. Good job, Sully. Okay, good job. So C3H8 plus 5O2 is 3CO2 plus 4H2O. Okay, good job, good job. So now it is balanced. And so we have, what do we have here? Okay, always write down what's given, and then always write down what's in the moles here. So the very first step is we need to get the molecular weights of all of these. Okay, another quick question, guys. Do you want me to show how to get the molecular weights, or do you want to just skip that part? Okay, do you want to just calculate the molecular weights, or do you want to actually show that, or should I just skip that? Okay, so if you want me to show the molecular weights, comment the word show, or if you want to skip the molecular weight calculation part, just comment skip. Okay, how do you put the 8 halves to put in the front of the H? How do you put 8 over 2? I'm sorry, Young Cook, I don't understand your question. How do you put 8 over 2 to put in the 4? Okay, show them, skip, show. Okay, I see some. Okay, I'm just gonna show it. So I got some for show. So first we need the molecular weight of C3H8. Okay, for C3H8, I'm basically gonna go to my periodic table, and then I gotta calculate out. Okay, I'm gonna calculate out. So I need someone else to calculate it for me though, okay? Because I want you guys to actually do it. So I want C3 here, okay? I'm gonna go to carbon here, and I see that's 12.011. Okay, so that's 12.011. I'm gonna do a 3. Okay, 3 times 12.011, right? Plus I have H8 here, and then I go to 8, that's 1.008, but I have 8 of those, right? So I'm gonna do 8 times 1.008. Okay, so someone please calculate that out. Let me know what you get, okay? So someone please calculate 3 times 12.011 plus 8 times 1.008. And then I'm gonna do the same thing for oxygen. So I'm going to do 2 times oxygen is going to be right over here. That's a 15.99. Okay. Okay. Times 15.99. Did you divide by 8? Did you divide 8 by 2 to get 4? So the hydrogen equals 8. Did you divide 8 by 2 to get 4? I multiplied 8 times 2 here. I multiplied 4 times 2 rather. So 4 times 2 equals 8. So I have 8H on the right and then 8H on the left. Okay, did that make sense? So I have 8H on the right and 8H on the left. Okay, so Marx is 44.097. Marx is 44.097. Okay, very good. So that was for propane here. And then I need the one for oxygen. Okay, and then I need the one for oxygen. Same thing for CO2. So let's repeat that process for CO2 and H2O. So for CO2, I'm gonna do 12.011 times 2 times 15 plus 2 times 15.99. 15.99. Okay, good. And then I'm going to do 2 times 1.008 plus a 15.99. Okay, and then guys, someone help me out here with these calculations. Okay, I know oxygen is approximately 32, so I'm going to round that up to a 32 grams per mole. I know water is approximately 18, so I'm going to round up water to approximately 18 grams per mole. Okay, so now I'm done with that. So now I'm done here. I have all of them, but I just need one more help here. So someone please help me out with CO2 here. Okay, if I'm not mistaken, for CO2 it should be approximately 32 plus 12. It should be approximately 44 as well, if I'm not mistaken. 44 grams per mole. Okay. Sí, soy mexicano, my friend. Liz the goat. Liz the goat. Mark says 43.991. Guys, let's get that more accurate one. 43.991. Okay. All right. Thank you, Mark. All right, we're doing stoichiometry right now, and then we're doing Gen Chem right now, and then we're gonna do physics in a little bit. Okay, this is gonna be our last one for Gen Chem. Okay, guys, so now what's the first step? So if you were here earlier, what's the first step? We gotta go back to our recipe here. So what did we say the first step was? Step 1, start with what you have, okay? Step 1 is start with what you have. So what do we have here, guys? What do we have here? We have what's given. So check what's given. They gave us 96.1 grams of C3H8. And what do we want? We want grams of CO2, okay? So step 1, always write with what you have. Always start with what you have. Step 1, start with what you have. Start with what you have. Start with what you have. Okay, guys, so what do I have again? I have, again, 96.1 grams of C3H8. Okay, I have 96.1 grams of C3H8. Okay, now what I gotta do, I gotta convert everything into moles. Why moles, guys? Because, guys, moles is the recipe. Remember when we were talking about eggs and flour? I forgot to mention that this was actually our secret recipe for the moles, okay? So even though we had 2 eggs and 3 cups of flour, I was actually secretly teaching you that this is actually moles. So if you understand this, you're actually understanding chemistry. So we got to convert this to moles so we can see the recipe. Okay, so now we're going to start with 96.1 grams of C3H8. Amber, thank you for the follow. And then we're going to convert this to moles, guys. So how do I convert 96.1 grams of C3H8 into moles? Guys, can someone comment down below? How do I calculate? How do I convert 96.1 grams of C3H8 into moles? Okay, so I'm going to give you guys a hint, okay? So I'm going to give you guys a hint. So I'm going to take my 96 grams of C3H8, and then I already know this is 44.1 grams per mole, right? Exactly, right? Tony, good job. I don't even understand why they're called moles. I gotta go. Yeah, it's not like moles like animals. It's like moles like the number here, okay? So I have 44.1, right? I have 44.1 here grams per mole here. Okay, does everyone understand why I did 44.1 grams per mole here on the denominator? Okay, if you're understanding, put a thumbs up. Why I divided by grams per mole? If you divide it by grams per mole, no, guys, we're not doing Avogadro. Guys, we're not doing Avogadro's number. We're not calculating the number of atoms. Avogadro's number is for atoms, okay? Okay, so guys, we're doing in moles because that's the periodic table. Okay, that's a really common misconception. We're not getting atoms here, we're getting moles here. So I'm going to divide grams with grams. I'm going to get moles here. Okay, so I'm seeing some thumbs up here, so I'm thinking that you guys pretty much got it here. And then the next thing we're going to do is convert our recipe here. So now we got to convert our recipe. Okay, we're gonna convert our recipe here, and then we're gonna basically see, all right, we have C3H8, and then we have to get our moles of CO2. So why do we want moles of CO2? Because they said we want grams of CO2. But before we get grams of CO2, we're gonna get moles of CO2. Avogadro's number is only for small particles. This is to calculate grams or moles. No, guys, Avogadro's number is to calculate number of atoms. Okay, Avogadro's number is to calculate the total number of atoms. It has nothing to do with this part, guys. So Avogadro's number has nothing to do with this part. Okay, so do not use Avogadro's number for stoichiometry here. Okay, yeah, thank you, Shore Shredder. Unfortunately, that's not true, Tony. We can definitely clarify Avogadro's number. We're not using Avogadro's number here, guys, because this is stoichiometry. We're not calculating atoms, we're calculating total number of moles. So what do? I go back to my recipe. Guys, remember when we talked about cookies and eggs and flour? What did I do? I used my recipe to get my total number of cookies, okay? So back then when I did eggs to cookies, I said we had 2 eggs for every 10 cookies, okay? So back then when we said 2 eggs for every 10 cookies, I divided by 2 and I multiplied by 10. Okay, so same exact thing over here. Yes, this is called stoichiometry, okay? So same thing over here. So this is my eggs, okay? On my left-hand side, this is the reactant. On my right-hand side was the product. So I see I have 1 mole of reactant here, 1 mole of C3H8. So I'm going to put 1 mole of C3H8 here. And then I'm going to put 3 moles of product, CO2. So 3 moles of CO2. Guys, does everyone understand why I put a 1 down here and a 3 up here? Okay, if you're understanding why I put a 1 down here and a 3 up here, go ahead and put a thumbs up down in the chat. Okay, if you're understanding why I put a 1 mole of C3H8, okay, because I want to cancel out this moles, okay, and then a moles of CO2, go ahead and put a thumbs up in the chat. Okay, so this period says no. Okay, so period says no. So if you don't get it, I'm seeing some thumbs down this time. Okay, this time I'm seeing some thumbs down. Okay, guys, we do not need Avogadro's number. We do not need Avogadro's number this time, guys. We're doing stoichiometry here, okay? Guys, we're doing stoichiometry. Let's do a quick recap. Okay, let's do a quick recap because I'm seeing some confusion here. So guys, let's do a quick recap. What did we say last time? We said for a recipe, we said we had 2 eggs and 3 cups of flour. So we have 2 eggs for 3 cups of flour and we made 10 cookies, right? So if I went to the store and then I bought 4 eggs and 5 cups of flour, then I'm gonna see how many cookies I made, right guys? So this is called stoichiometry. So what I did was I did step 1, start with what I have. So what do I have? I have my 4 eggs and 5 cups of flour, right? So let's review what we did here. Okay, so let's review what we did. So I'm gonna basically start with what I have. So I have my reactants are on the left hand side. So my eggs are on the left hand side, right? And then I multiplied by the 4 eggs and the 2 eggs here so I can cancel those out. I divided that rather. And then I had my 10 cookies on top. So this number in green, I'm going to highlight this here in green because I think this is the trickiest part for everyone. It was tricky for me and it's tricky for a lot of people too. Okay, we're not using Avogadro's number. We're not using Avocado's number here. We're doing the ratio. We're doing the recipe here. Okay, so this number 2 on the bottom here is from this number 2. Okay, so this number 2 from the eggs is down over here, and this number 10 is from cookies. Okay, similarly for the cups of flour, we said that we have 3 cups of flour from the recipe and 10 cookies up on top. Guys, if everyone's understanding the cookie example, put another thumbs up. Okay, if everyone's understanding the cookie example, put a thumbs up if that made some sense, if that started to clarify the cookies, guys. Okay, so this is step 1, guys. We do not need thumbs up. Okay, Mark says thumbs up. Rat said thumbs up. Sure. Okay, good, guys. So you guys are understanding the cookie example, right? So now let's use that as the same exact thing, right? So now let's use that the exact same way here. So on the left hand side, these are our cookies and our flour. This is the reactants, and then on the product is our cookies, rather. I meant to say that on the left hand side is our eggs and our flour, and on the right hand side we have the products. That's our cookies, right? So what do I do here? I divide by the stoichiometric coefficient here. I divide by a 1 here. So that's why I'm dividing by 1 here, just like how I divided by my number of eggs. And then I multiply by a 3. Okay, so I divided by a 1 here because I want to cancel out the moles. And then I multiply by a 3 because I want to get moles of CO2. Okay? Nadia says I get lost when this gets reversed. Oh yeah, absolutely. When we go backwards, it's getting even more confusing. Okay, but let me know if that clarified. Now do we understand why we have moles, 1 mole on the bottom and 3 moles up on top? Okay, that's true. Okay, that's true, sure. So Avogadro's number is a constant with units 1 over mole. Okay. All right, awesome. Ale, good job, good job. All right, guys. So now we have moles of CO2, and someone calculate this out. Okay, so someone calculate out what is 96.1 times 3 divided by 44.1. Okay, so someone please calculate how many moles of product we formed. Okay, so someone please in the comments calculate out 96.1 times 3 divided by 44.1. Okay, and we're going to do the same exact thing. So we're going to do the same exact thing, but now we're going to do oxygen. We just did it for C3H8. Now we got to do it for oxygen here. All right, so for oxygen, guys, we're going to start with what we have. Step 1, start with what you have. Okay, so I have 400 grams of oxygen. So I'm going to start with 400 grams of oxygen. Now that I have 400 grams of oxygen, what's the next thing I have to do? Now that I started with the first thing of 400 grams of oxygen, what do I got to multiply first? I like OChem more. Period says I'm confused. 6.53. Guys, so someone said 6.53. Where is that 6.53 from? Do you guys calculate that out for me? Okay, thank you. So let's see here. I'm learning this at UCLA and I don't seem to get it. Please help. I got you. Okay, very good. So someone, Alice said 1 mole over 32 grams. Good job. Good job, twin. You're cooking right there. You're cooking. So we're doing 1 mole over 32 grams. Good job. You're just cooking right up here. So we cancel out our grams, okay? Good job, good job, good job. So guys, does everyone understand what Ale did? We basically divided by the 32 grams because that was our conversion to get to moles, okay? Good job. You guys are cooking, okay? So I saw 2 different answers. I saw 2 different answers for this answer here. So let's calculate this out because I think someone I saw 2 different answers here. So I'm gonna do 96.1 times 3, right? 96.1 times 3. 96.1 times 3 divided by 44.1. So I got 6.53. I got 6.53. There you go. Yeah. Okay. Mark was correct. Whoever said 4, I think you made a small mistake. Okay. I got what Mark got. So I could put 6.537. Okay. So I'm going to put a 6.537 here for moles of CO2 formed from the moles of CO2 formed from the C3H8, right, guys? Okay, Soli, thank you for the love. Guys, Amelia, thank you for the heart me. Loyal, thank you for the awesome. I have not been thanking you guys. I've been kind of low-key locked in. Guys, are we ready for the next step? What's the next step from here? Now we calculated moles of oxygen. What do we got to calculate next? What do we got to calculate next here? Let me make this bigger. Guys, we hit 4,000 likes today. We got 29 new followers, 2 gifts, no, 18 new followers and 3 gifts. Thank you, Shore. So guys, what's the next step here? Now we calculated the moles of CO2, but we got to calculate the moles of CO2 from oxygen here. So now that we have moles of oxygen, what do we do next here, guys? Okay, so what did we do last time? Remember, we said our recipe here. This is the hardest part for most people, including me, guys. Okay, trust me. When I was in high school and college, I did not get this at all. Okay, trust me. I was struggling here. So this is the hardest part here. So this is the hard part that we're on right now here. So let's try again. So what numbers do I got to put over here? Okay, for the recipe. Remember, this part in blue is the recipe. So what's the recipe? It's the reaction. Okay, so whenever I teach this to my chem students, I always say that this is the recipe here. So what's the recipe call for? Look at the units, guys. Look at the units. So what's on the units, guys? Okay, we gotta put moles. Okay, we gotta do mole to mole. Yep, I got you on math as well, twin. I got you on math, chem, and physics. Okay, I know we're gonna do moles, but what's gonna go on top? What's gonna go on top here? What numbers am I gonna put on the top and the bottom? I found a very fast shortcut for limiting reagents if you want me to share. Please do. Okay, guys, what am I going to put in the recipe here? What numbers am I going to put on top and the bottom here? 1 and 4. 1 and 4. I'm sorry, twin, that is not correct. 1 and 4 is not correct. Okay, last time we did a 3 and a 1. Okay, I'm sorry, twin, that is not correct. Okay, we got to do moles. I'm going to give you another hint. So I know I'm going to want moles of O2 on the bottom and CO2 up on top. So guys, the first one to get this correct gets a shout out here. Okay, First one to get this correct gets a shout out. So what number do I put up on top here? Okay, Dexter says 3 and a 1. Claudia says I just left 3 and a 1, 3 and a 1. Good job, good job. Okay, 3 and a 5, guys. It's gonna be 3 and a 5. Guys, it's gonna be 3 and a 5. So I'm gonna put a 3 up on top here and a 5 down here. This is the hardest part. This is the most tricky part. Where does the 3 come from? The 3 comes from the CO2 here. So that's why I put a 3 from the CO2. And the 5 comes from the oxygen. Remember, we're converting our oxygen here. So I look at the recipe here. So make sure you zoom out and see the recipe here, okay? So that's going to be our next calculation. Guys, if this is making sense, put a thumbs up down in the chat. If this actually made sense and we're cooking right now, put a thumbs up. If you're still cooked, put a crying emoji because we're still not getting it, okay? Put a thumbs down if you're still confused. Where did I get these numbers from? These numbers were given in my textbook, and then these numbers we calculated. So this was given in the problem statement. Okay, the numbers that were given in the problem statement were 96.1 grams of C3H8. Sully says happy face, thumbs up. Dexter, good job, good job. Nadia says thumbs up. Okay, Eden says, what is that? Is that a duck? Is that a rooster? I don't know what that is. It looks like a duck. Okay, guys, so we're about to calculate. We're almost done with this reaction here. We're about to calculate our our moles of CO2. So now I'm going to take my 400 here, my 400 times my 3 divided my 32 times 5. So 400 times 3. So we're going to do 400 times 3 divided by 400 times 3 divided by 32 times 5. Divided by 32 times 5 here. So I basically, whoops, you guys can't see that. So let's bring that down. So I did 400 times 3 divided by 32 times 5. That's 7.5. Okay, good job, good job. So we got 7.5 here. All right, so now I got 7.5 moles of CO2 from the oxygen and 6.5 moles of CO2 from the water. You already know what I'm going to ask you guys next, guys. You already know what I'm going to ask you next. We're going to do a quick poll. Okay, so we have 6.5 moles of CO2 from the oxygen, and then we got 7.5 moles from the CO2. So you already know which one I'm going to ask next. I'm going to ask which one is limiting. Okay, which one is limiting? So I'm going to pull up a poll right here. So I'm going to say CO2. If you think CO2 is limiting, think about that. Or if you think that that one's in excess, let me know. Or if you think that, I meant to say oxygen or C3H8. So oxygen or C3H8, guys. So which one is limiting here? Which one is limiting? So you got 5 more seconds to think about it. Got 5 more seconds to think about it. So which one is limiting now, guys? Okay, 60 seconds on the clock. So if you think that C3H8 is limiting, you're gonna vote for a happy face emoji. If you think that oxygen O2 is limiting, you're gonna vote for oxygen. Okay, C3H8 is propane. Good job, Nadia. Good job, Jackson, Mark, Insane, Sujan. Good job. Taco, 3 tacos. Mark, Soli, Rat. Good job. Good job. Guys, you guys are cooking. Oh my God, you guys are cooking. Nine answers. 9 answers. Okay, the one with the least moles. Okay, that is correct. You guys are cooking. Oh my gosh. Guys, drop some party emojis, drop some fire, drop some pots, drop some cooking emojis, drop some fire emojis. You guys are cooking this up. 10 more seconds left. So far, no one got it wrong. 5 more seconds left. 5 more seconds left. Not a single... Okay, time's up. Not a single person got that wrong. You guys are absolutely cooking. So drop some fire and some pot emojis. You guys are absolutely cooking. So we calculated, we got 6.537 moles of CO2. So therefore, this one is less than oxygen. Okay, just in case, let's make that very clear. So 6.537 moles of CO2, which came from the C3H8, is less than the 7.5 moles of CO2 from the oxygen. So therefore C3H8 is limiting. So whichever one forms less is limiting. Okay, hi Christy, good afternoon. Okay guys, so that was the end of that reaction, guys. I think I'm gonna do another, take a look here. So anyone that was here earlier, you saw that we did a custom live stream today where we said we were gonna do Gen Chem We said we're going to do Gen Chem for the first hour, and we're going to do physics next. So guys, we are over time. It is 6:20 p.m. my time. It is time for physics. So that is going to be the end of the AP chemistry lesson for today. But don't worry, guys. If you still need help, you can check out my YouTube channel where I go over AP chemistry topics just like this, as well as on my TikTok page. If you also need tutoring, you can sign up for a free consultation call at engineeringminds.co. Guys, shouts out Jackson. Jackson put like a high emoji or something. Shouts out Jackson, who helped me build out my website. Go to engineeringminds.co, where you can see up all the resources. So we're building out these practice problems for totally free, guys. So if you click on this button that says explore resources, you can go down here and click on the topics that say chemistry. And so if you need more help with chem, this is where you're going to find every single topic you're ever going to need, whether it's stoichiometry, vapor pressure, Lewis structures, etc. Okay, guys? So this is 100% free at the link in bio. Okay, so shouts out Jackson, guys. Shouts out Jackson that helped me build the Discord. How's it going? How's it going? Guys, we're switching up to physics now. I promised the physics people because that was a big request here. So if you're here for physics, go ahead and drop a thumbs up and comment W physics if that's something that you guys want to do. Okay, we're going to switch gears here to physics. Once again, my name is Dr. Andrew Sanchez, PhD in chemical engineering. And thank you guys so much for joining the chemistry session. We're going to switch gears here to physics for one more hour, and then we're doing Q&A, and then we'll end it for today. I do go live every single week, Monday through Thursday. So here's my live stream schedule. And guys, if you need any help with math, chemistry, physics, you can join up here on the website engineeringminds.co. So guys, we're going to do physics first. We're going to do physics rest, and then we'll do Q&A. Okay, guys. So thank you, Nadia. Says W physics, guys. Thank you so much. So we're going to do physics here, but here's my live stream schedule. Monday through Thursday at 6 o'clock PST and 9 o'clock EST. You can sign up for tutoring at the link in my website, engineeringminds.co. Oh no, guys, I did my outro and now people thought that it was over. Guys, this is not over. It's time for physics. We are still going. I did my outro and people thought, oh, it's over. Guys, this is not over. We are still going. We're going to do physics. And now here's the next topic here. What is the next topic? Any grade level math? Yeah, I can do any level math. Particularly, I do upper level though. So I can do algebra, trig, pre-calculus, or calculus. Yep, that's what I think. Okay, guys, so let me know which topic in physics should we focus on. Should we do vectors? Should we do kinematics? Should we do acceleration versus velocity? Should we do force vectors, Newton's laws? What topic should we do in physics? Or should we do electricity and magnetism, thermal physics, heat energy, things like that? Waves. What topic in physics should we do first, guys? Okay. Lauren says force vectors. All right, awesome. Okay, guys, so we're gonna do physics, and then Nadia says heat energy. Anything is more important. Well, guys, they're all really important. So I'm gonna say force vectors is super important because we need to understand how to do the the geometric angles for our force vectors here. So I think what we're gonna do is we're gonna do force vectors, and then we'll do thermal physics for Nadia here. Okay. So let's start with basically force vectors. And then guys, I promise if you follow along and use your notes, get out your notes, and if you're following along in physics class, I promise it's gonna make a ton of sense. It's gonna help you so much. Okay, I'm gonna tell you all the little secrets that I wish someone told me that I haven't seen anyone else really talk about it much online. I do see a lot of physics content, but I haven't seen people talk about it the way that I talk about it. So really excited that you guys are here today, and I'm gonna make this super easy. Okay. So guys, we're going to do our force vectors, and let's start with our very first case here. We're going to call this case number 1, which is a box on a flat plane. So I'm going to call this case 1. This is a box on a flat plane. Okay. So guys, I need to know, are you guys in college or high school? And do you want to see this with calculus or without calculus today? Or a little bit of both? So if you want to see this with calculus, comment calculus. If you want to see without, comment the word without. Okay. And then I'm going to basically draw this out here. So do you do a high school math tutoring? Yes, I got you on high school math tutoring. So it can be, you know, algebra, trigonometry, pre-calculus, or calculus. Okay, all the information is there as well. So Lawrence's college with calculus, calc, and everyone is saying calc, guys. So we're gonna do it the traditional way with calculus here. So let's start simple. We're gonna have our case one for force vectors box on a flat plane here, guys. So I'm gonna draw this box here, and then I'm gonna do a down arrow to indicate that this is what? What is this first arrow going to indicate here? So this down arrow on a flat plane indicates which force vector we're gonna do first. Okay, we're gonna do the first vector here is going to be what? Weight, exactly, gravity, weight. Okay, I'm gonna call this W for mg. Okay, everyone comment W. Everyone comment W, guys. Okay, very good. And then is this positive or negative? Is this positive or negative? Okay, so what is the, and then which direction is it in? Which direction is it in? So a vector is gonna have brackets, guys. So make sure a vector always has brackets. So if it's a vector, which I'm gonna denote with this arrow symbol, it's gonna have brackets. Thank you, guys. Thank you. You guys are saying W. Thank you. Okay. So I'm gonna say it's 0 in the x direction, and then I'm gonna say negative mg in the y direction here. So this is a 0 in the x direction and a negative mg in the y direction. All right, guys, what other forces do we need? Do we know Newton's third law? Did your professors talk about Newton's third law yet? Okay, what is Newton's third law? Okay, so what is Newton's third law for this box here? What other force are we going to add here? Normal force, Gustavo. Good job, good job. So I have my downward force pointing down, so that's my gravity vector, that's my gravity, that's my weight. And the normal force is pointing up because Newton's third law indicates that for every action there's an equal and opposite reaction. So N indicates the normal force, and let's write this down real quick just for everyone to understand this fully. Okay, W stands for the weight of the box, which is mass times gravity. And then N stands for the normal force, which is the equal and opposite reaction force according to Newton's third law. Now, you guys said with calculus here, so let's go ahead and apply Newton's second law here with calculus. So you guys said with calculus. So Newton's second law with calculus states the following. It says that the summation of all forces is equal to the mass times acceleration of this force vector here. So the left-hand side is going to be our summation of all forces, and the right-hand side is going to be the acceleration of this vector here, of this system here. But right now, what is our acceleration, guys? Is this system dynamic or static? Is this system dynamic or static? Okay, is this system dynamic or static? How do we know something is static or dynamic? If it's accelerating, it's going to be dynamic. Good, Carl, good job. So this is going to be static. So because it's static, I'm going to cancel out my acceleration. Okay, good job, guys. So that's going to be static, so acceleration equals 0. And then I'm going to simplify my force vectors as the summation of all forces is equal to 0. And we're going to might as well box this. By the way, I forgot to emphasize this equation is super important. This is Newton's second law. Okay, this is Newton's second law. And because this is static, we're going to box these two equations, okay, to indicate that it's going to be static here. Okay, let me just box this one. Okay, so if something is static, that means not accelerating. So we're going to say the summation of all forces equals 0. I just know because I have a third sense here, guys. All right, so this is our system, and effectively we are solved here. We are done because this system is not moving. So this is our base case here, guys, for a box on a flat plane. So let me know if this is making sense. If this is making sense and we're cooking up here, put a thumbs up. If this is making sense, put a thumbs up. If you're confused so far, put a crying emoji. Okay, and so this is a box on a flat plane. So this is our base case. We are done with this problem. So, all right, Nadia says thumbs up. Okay, good job, guys. So now what we're gonna do is we're gonna do another force vector, and let's make our case number 2. Let's make our case number 2 a box with a tension force applied at an angle theta. So we have a box on a flat plane, But now what we're going to do is we're going to add a tension force, T. Okay, guys, so we're going to repeat that process. So last time we had a box on a flat plane that was static here. But now what we're going to do, guys, is basically draw out this force vector. Thank you, Gustavo. Okay, let's say no friction first. Let's say no friction. Tension, but no friction. We're going to say frictionless first. Okay, that will be case 3, guys. Okay, so let's say tension force here is applied at an angle theta. And let's say our angle theta, guys, is basically with respect to the horizontal. Okay, and then here's where we're going to have a little bit of calculus here. We're going to basically apply our force vectors here. And then what are our forces again here? What was our forces? Okay, so again, we're going to have gravity. That's not going to change. Gravity is always present. We're going to say 0 in the x direction and negative mg in the y direction. Guys, are you familiar with the unit vectors? Another way of writing this is going to be a negative mg in the j hat direction here. Okay, the j hat is called a unit vector. So if you guys need help on unit vectors, comment the word unit vector. We can talk about the unit vectors. So the j hat is called a unit vector. Now the normal force is still applied in the upwards direction. Okay, so now the normal force is going to be equal and opposite to our gravity. So this one's going to be a positive mg here in the y direction. But then this time we have a tension force. So now when we apply Newton's second law, it's not going to be static. It's not going to be static. We're going to have a dynamic system here. So what is Newton's second law again, guys? Newton's second law is going to say that the force applied on the system is equal to the mass times the acceleration on the system. And our job is to solve for the acceleration or the tension force. Most of the times, they're going to give you the acceleration because this is easily measured. And then we're going to have to calculate tension. Yes, absolutely, Alexis. I do tutoring. All the information is up on the link in bio, engineeringminds.co. Okay, and on the left-hand side, we have the summation of all forces. Guys, is everyone familiar with the summation symbol? Guys, let me do a quick poll. I want to see if you're familiar with the summation symbol. So let me just do a quick poll because sometimes people are scared about the notation. So let me see if you do. Let me see if you're understanding the summation symbol. So I'm going to say, do you understand sigma? Okay, and then this is basically with calculus. So here's my poll here. Okay, so there's going to be, do you understand sigma? If you understand sigma, you're going to vote for a happy face. If you don't understand sigma and you're cooked, you're going to vote for a crying emoji. Okay, quick poll. So quick poll. Okay, all right, quick poll. So do you guys understand sigma? Okay, sigma is this symbol here. Do you understand what this symbol indicates? Okay, most of you guys and gals have taken calculus. Okay, so most of you understand this one. Okay, everyone understands sigma, so that's really good. So what does sigma indicate? What does the summation of all forces indicate? Okay, so I don't need to talk about that because everyone seems to understand that, okay? So what does the summation of all forces indicate here? So that indicates that on the right-hand side, we're going to have the acceleration, but on the left-hand side, we need to sum up all the forces, okay? And so the sum of all forces, I'm just going to take one force one at a time. So my first force, I'm going to call that the normal force, okay? So I'm going to say that the normal force, okay, plus the tension force, plus the gravitational force is equal to 0. Okay, your professors won't show you how to do it this way. Your professors are going to make it too complicated, but I'm just making it really simple. I just see I have 3 forces, 1, 2, 3, and then I'm saying I have, okay, that's my normal force, my tension force, and my gravity, and then I'm going to set that equal to m times a. All right, so now what do I got to do, guys? What's the next step from here? What's the next step from here? Tips for physics 1. Do what I'm doing. Break it down step by step. Try to visualize it step by step here. Follow along here. Okay, follow along because I have lots of tips for physics. Okay, the next step from here is basically we applied Newton's second law here. This is again Newton's second law. What's the next step from here? Okay, keep practicing visualizing what the system is gonna indicate here. So now I'm gonna apply the left-hand side. I'm going to do my x component analysis. I'm going to break it up into the right hand side. Okay, so on the left hand side, I'm going to just copy and paste it. So the first tip I have for you, if you're confused about physics, write it in vector form, and then I'm just going to make a copy and paste here. So I'm going to say n x plus tx plus gx. I'm not doing any math. I'm not thinking about anything. I'm not calculating anything. I'm literally just writing whatever formula I put. I just put it in the x direction here. Okay, so if you systematize it, okay, then it's going to make it easier to comprehend. And the same thing for the right hand side. I'm not thinking. I'm just going to make a copy and paste here. Tx, ny, ty, gy, may here. Okay. All right, so now, what we're gonna see here is, let's see what we can cancel out here. So we're gonna have some acceleration in the x and acceleration in the right here. Okay, draw a free body diagram. We have that here, my physics brother. Absolutely. After I visualize, I don't know which formula to use. So if you don't know which formula to use, this is in the Newton's second law free body diagram. So now what we're going to form is so now let's go ahead and analyze this. So this is nx. So what does nx indicate, guys? What does nx indicate? N indicates the normal force and x indicates the horizontal component, right? But do we have anything? We already said this was 0. Guys. So I'm going to cancel this out. So I'm going to say this is 0. No thinking involved. What about tension? We got to do tension, so I'm going to leave tension for last here. I'm going to call this Tx and Ty for tension. What about G? What about Gy? Guys, G is only in one direction here. Haha, one direction. So G is also 0. So I'm going to put 0 in the x direction here. Okay? And look, I have a new equation here. I'm going to say that Tx is going to be equal to ma in the x direction. So I'm going to box this and I'm going to put a 1 here. This is my first equation. Guys, did you see how I analyzed the system? I basically use my drawing as a free body diagram, and I don't have any calculations yet. All I did was just visualize my diagram, and then I applied Newton's second law. So if you're understanding this, go ahead and put a thumbs up down below. Okay, if you understand what I did for system 2 here, this is case number 2 with a box on a flat plane with tension at an angle on a frictionless surface. Okay, yeah, your professors won't teach you this way. Your professor's trying to make it complicated. Guys, physics is not as complicated as it seems. Okay, Drea says thumbs down. Sonic says thumbs down. Guys, what part was confusing here? So one more time, I have my tension is going to the right. I have my normal force is going up here, and then gravity is pulling down. So what I did was I wrote out my general equation. Guys, this one over here is my general equation. So on the left hand side, I have 3 vectors, and then on the right hand side, I have mass times acceleration. So this vector number 1, vector number 2, and vector number 3. On the left hand side, I did the x component, but I said I got rid of n and g. Why did I get rid of n and g in the x direction? Guys, if I look at the drawing, why don't I have n and g in the x direction? Let's take a look at n here. So n is pointing, where is n pointing? Is it pointing up? Is it pointing down? Is it pointing to the side or at an angle? Yes, this is Newton's laws. Which direction is n pointing? Exactly, right? So n is pointing up, okay? N is pointing up. It is not pointing at an angle. So n is pointing up. So n is not pointing at an angle, so that's why I neglected my nx here. Same for g. So g is pointing down. It is not pointing at an angle. How do you know to add or subtract the sum of all forces in x or y? I'm going to, that's the beauty of it. I just added everything. Okay, I don't care which direction it is. So if it's pointing up, you're going to make it positive up. If it's pointing down, you're going to make it negative. Okay, Drea says, oh, got it. Okay, Drea says, oh, got it. So that was for my first one. That was for number 1. That was for x direction. Remember x, guys? Remember, x is horizontal, y is vertical. Okay, so x is horizontal, y is vertical. Is this university level? Guys, this is college level, yes, but I'm trying to make it easy whether you're in high school or college. Okay, and then guys, now we're going to do equation number 2. This is for the y direction. So now we're going to have ny, and we're going to have ty and gy. All right, now we can cancel out ny. So what is mg here, guys? What is mg here? Okay, and what is mg here? Okay, I mean, I gave it away. I meant to say what is ny and what is gy. So ny is a positive mg and gy is a negative mg. So for my ny, I have a positive mg, and then for my gy, I have a negative mg here. So then this gonna cancel out. So I'm gonna cancel out this, and then I have my tension is an may here. Okay, so I have a tension in the y direction is may. Now I'm going to call this equation 2. Okay, so now I have my tension in the x and tension in the y. And very good. So I got mass times gravity. So guys, did everyone understand how I got equation number 2? Okay, does everyone understand how I got equation number 2? Jamie, yes, these are recorded, but I'm not going to lie. I've been lagging it on posting these because they're too long, because this one's an hour and 40 minutes. Guys, should I post this? Let me know if I should post this. Maybe I'll just post this anyway. Okay, and then figure out if I can just post it on YouTube. So what we're going to do here, guys, is now we have our 2 equations. So any questions about how I got equation number 1 and equation number 2? Okay, everyone's saying post it. Okay, guys, everyone's saying post it. Can you please post this one? Okay, guys, I'm gonna work on posting that tonight. All right. Yeah, I can do electric problems next. So guys, I have equation number 1, which says that Tx is max and then tension Y is may. So if there's any questions here, let me know. Now I have another equation. I didn't even define T yet. Here. But guys, this is where it gets really, really easy, because this is a geometry problem. I see this is a hypotenuse of a triangle with components x and y. And when I see a hypotenuse with the components of x and y, which equation are we going to use? Which theorem are we going to use for a right-hand triangle here? Which theorem are we going to do for a right-hand triangle? Okay, so I know I have Tx and then I have Ty, right? So if I want to get the tension T in terms of the acceleration, how would I use, which equation would I use here? Which theorem would I use for a right-hand triangle? Think back to your geometry class, guys, in high school. Think back to your high school geometry days or your pre-calculus days if you took pre-calculus here. So if I have Tx here, I'm going to replace my Tx. I already know that's ma in the x direction. Okay, and then I have Ty, and that's ma in the y direction. So I already have these numbers here. Notice that I didn't even need any numbers. I'm not even doing any math yet. Thank you, Hijab. Appreciate you. Thank you. 90 degrees. Pythagorean theorem. There it is. Garcia was the first one. Pythagorean theorem. Guys, what's the Pythagorean theorem? Guys, everyone put the Pythagorean theorem down in the chat. Does everyone know the Pythagorean theorem? Does everyone know the Pythagorean theorem? Guys, if you know the Pythagorean theorem, put it down in the chat here. Okay? Okay, Garcia says inverse tan of inverse tan. Okay, that's hard to get theta. Good job. So, okay, good job. So AP says a squared plus b squared equals c squared. Poopy, welcome in. Doing vectors right now in physics. A squared. Matthew says yes. Plus, I have an exam coming up. Do you do problems with what? Can you do problems with forget? Forces. We're doing problems with forces. Sherlyn. Okay. Oh, it was Leoni first, not gonna lie, it was Leoni. I miss Leoni. Okay, Pythagorean says that a squared plus b squared equals c squared. So guys, which ones are a, which ones are b, which ones are c here? Which ones are a, which ones are b, which ones are c? Okay? So remember, our a is our side here, our a is our adjacent side, our b is our opposite side. So I'm gonna say that this is a ta, this is a tx, this is equal to our tx here. And then this tension is the hypotenuse here. So I'm going to write a formula in terms of the tension forces here. I'm going to say that my right-hand side is my hypotenuse, is a t squared here. And then my left-hand side is the x term. So I'm going to say x squared plus y squared equals t squared. Okay, but instead of my x here, I'm going to put my, what's my tx here? I'm going to put my tx is max. Okay, so I'm going to put ma in the x direction. But guys, that's just my x squared. So max squared plus may squared, and that's going to be t squared. Okay, does everyone understand how I use the Pythagorean theorem to do this here so far? Okay, does everyone understand how I use the Pythagorean theorem? And that's pretty much going to be, let's see, how we get this here. What else can I do here? How else can I solve this system? How else can I solve this system? I'm realizing I'm going a little bit higher level than I originally intended because I wanted to make this easy, but we haven't even seen any numbers yet. So guys, how would I do this in terms of numbers? Okay, I would have to basically apply this using my formula for sine and cosine now. So if this is my tx, would my tx correspond to a cosine or a sine? Guys, what's the formula for cosine? What's the formula for cosine? Did we do SOHCAHTOA? Guys, let me know if you guys remember SOHCAHTOA. Okay, so SOHCAHTOA means what? SOHCAHTOA, how do we apply SOHCAHTOA? Okay, all right, very good. So Matthew says cosine theta, right? So we're going to say this is a t cosine of theta because so stands for sine. Cosine stands for adjacent, right? Exactly, guys, right? So very good. So now we're going to say that ty is going to be t sine of theta. Okay, do we have the value or the angle of theta? Right now, no, guys. I did a little bit higher level than intended. Right now, we have no numbers. I was kind of just doing a general case here, but if you guys give me numbers, we can plug it in. Quick random question. Did you get a degree in science or art starting off? My bachelor's was in chemical engineering. My PhD was as well, Leslie. So I basically just did my bachelor's and my PhD in chemie. Okay. So that's pretty much it for this system, guys. That's pretty much all we have to be able to solve here because we don't have any numbers. So that's going to be the solution to this equation here. It's just going to be the Pythagorean theorem with our tx and our t cosine theta here. So guys, I think this is going to be a little bit higher level than originally intended. So how about we do some actual numbers here? How about we do some actual numbers? And if you guys give me some actual questions where you can join up on either the Discord or on the website, you can submit your questions with actual numbers. So just go to engineeringminds.co and then click that link that says TikTok Q&A. So that way we can see actual numbers and then I can respond as soon as possible, guys. So if you have any questions, go to engineeringminds.co and then drop in your questions here. Okay, what time do you get off from the live? I'm gonna go on for about like 40 more minutes, guys. Okay, Carl says for case 3, can you do incline problem? Absolutely. So let's do case 3, guys. Matthew, that was the answer. Unfortunately, I didn't give you guys any numbers, but your professor or your teacher would say, oh, the tension was 40 degrees. I mean, the tension was 40 newtons. Calculate the acceleration. Then if they give you the numbers, then we can use the Pythagorean theorem to get this, okay? So if they give you the numbers, we can use the Pythagorean theorem to get the acceleration or the angle here, okay? Okay, so guys, that was case number 2. So let's just do a quick recap. Because this is going a little bit theoretical and I don't want to be confusing theoretical. I want to be, helpful theoretical. So if this is confusing, you want to see numbers, let me know if you guys want to see actual numbers here. Okay, so guys, let's do a quick recap because for case 1, we had a box on a flat plane and it was totally static. So we had no equations here because all we said was F equals 0. Okay, and then for case 2, we said that we have a box on a plane with the tension force pulling up. So that's going to be case 2, and our final answer was just the Pythagorean theorem. Now what we're going to do is box on an inclined plane, and that one's going to be a little bit more complicated. Can you solve anything? No, not anything. Okay, sometimes guys, I'm a human too. I'm not like ChatGPT, guys. And guys, I struggle, dude. You have no idea how much I struggle with math and physics. Like, you have no idea how cooked I was, guys. If you would have told me 10 years ago that I would be like, doing my PhD and like helping other students, like I'd be like, no way, bro, you're cooked. Like, you're like literally not even getting this. How can you be helping other people when you don't get it yourself? Okay, Sherilyn says centripetal force and circular motion. Okay, that's a different topic. So I'm going to do case 3 here. I'm going to do case 3 and then I won't solve it completely because this one is a little bit more complicated. So case 3 is going to be a little bit more complicated. So I won't solve it completely, but we're going to do as much as we can. So first thing first, guys, what's going to be step 1, step 2? What's going to be step 1, step 2? So how can I get better at physics? Every time I sit down to study, I feel like I'm pulling my hair out. Okay, Sherilyn, like I said, I was just like you, Sherilyn. So I was like literally cooked. Oh, Leslie, thank you for the finger heart. You as well. Thank you for the finger heart. Okay, so how do you get better at physics? Okay, here's the secret. There is no secret. You literally have to just push through the confusion Okay, push through the anxiety, the fear of like, oh no, I'm gonna get this wrong, I'm gonna fail the test. I know, twin, that's how I felt too. I know, you have to push through. Okay, you do the problems, and even if you have no idea, you're gonna pretend, you gotta fake it till you make it, twin. That's basically what I did. I faked it till I made it, and that's how I got through physics and chem and calculus. Okay, so just sit down and study every single day. Do the problems, twin. Do the practice problems. Don't copy the book. Don't make the prettiest notes. Don't make every single color on your page show all the vectors. No, you don't care about the pretty notes. You got to do the problems, twin. Pretty notes are not going to get you that A. Doing problems will get you that A. Does that make sense? Step 1, pick English major. No. Practice and get stuff wrong. Exactly. When you fail, you're actually winning, because when you're failing, you're learning what's working, what's not working. There you go, Garcia's first one that I saw here. Okay, first step is normal force, gravitational force, and friction forces. Guys, do you want to do friction or no friction for this one? Do we want to do friction or no friction? Of course, Sherilyn, I got you. Guys, do you want to do friction or no friction? So I'm gonna start it with just the gravity. So I'm gonna do gravity pulling down. I'm gonna do gravity pulling down. And then I'm gonna do normal force pulling up. And then I'm going to say gravity is pulling down here. And then I'm going to say that, guys, imagine that there's a tension force. Let's get it even crazier. So this one I did with a client recently. Imagine that there's a tension force because there's a weight. So now we're doing a pulley system here. So I'm going to call this mass 1, and I'm going to call this mass 2. Let's say that mass 2 is really, really heavy. So let's say that mass 2 is greater than mass 1. So if mass 2 is greater than mass 1, which direction is the tension force, guys? If mass 2 is greater than mass 1, which direction is the tension force, and which direction is the friction? As an electrical engineer in retirement, you will never use it. Learn public speaking, project management. That's a really good talking point, guys. If you're scared about math, you're never going to use this. Even if you do engineering, you're never going to need it. You're going to do public speaking, marketing, things like that. Let's neglect drag, but let's neglect drag, but not friction. Okay, so let me color this one a little bit better. Okay, guys, I literally just said don't be OCD about your colors, but I'm getting a little bit OCD about my colors here, so I'm gonna color this one a little bit better. Okay, don't waste time coloring, guys. The perfect colors are not gonna help you lock in. Okay, so if M2 is greater than M1 in this pulley system, that means we're gonna have a tension force pulling up. Okay, and then we're gonna have a friction force. I'm gonna call this T, and then I'm gonna have a friction force pulling this to the side here. Okay, I'm gonna call this little f. Now, F is the friction, and F, I need to give you guys an equation. F is gonna be mu times the normal force. F is mu times the normal force. Okay, and so what I'm gonna do is I'm gonna put a gravitational force here, and I have to decompose here. So step 1 is to draw the diagram. We also need to do a basis here. Guys, we have two options. We can either do a x direction component and a y component up like this, or what we can do is we can rotate this in our minds and basically do another basis over here where I'm going to call this x prime, which is at an angle here. Okay, and then I'm going to call this y prime. This is also at an angle. So x prime is now our new basis direction. So I'm going to call this x prime, and this is y prime. It does not matter if this confuses you. You do not need it. This is actually going to help me to visualize. So I'm not going to do it this way because I know this confuses some people. But if you want, this is actually going to make it easier. For now, let's just focus with this. But the only problem with this angle is going to be we have this at an angle. We got to decompose our vectors here. So how do we do that? That was step number 1. Step number 2 is going to be Newton's second law. So what is Newton's second law, guys? So it's going to be Newton's second law is going to be F equals ma. Okay? So summation of all forces. We're going to ignore drag, but we're going to include friction. It's kinetic friction because it's moving. Okay, very good. I should have put a K right here. I should put a K right here. There you go. So K stands for kinetic. Guys, and friction, by the way, is like when you rub your hands, That's friction, right? So that's called kinetic friction because there's energy transfer between your skin cells. All right, guys, so that's going to be our first equation here. And so how do we apply this equation? No thinking yet. Notice that I didn't even decompose my vectors. Your professors are going to overcomplicate it. Guys, decompose your vectors. Yeah, we're going to do that, twin. But first, let's just write the general equation. Let's just write the general equation before we decompose our vectors. So what vectors do we have here? The general equation here, I'm going to have gravity, tension, normal, and friction. So someone said, how do you know if it's positive or negative? Guys, I don't care. I don't care because I'm just going to write the general equation and then I'm going to worry about if it's positive or negative. So if you have it step by step, that's going to make it so much easier. So notice that everything I just wrote as g plus t plus n plus f. I don't care if it's going to the right or to the left. I don't want to do thinking because that's going to cause decision fatigue and freak me out and make me scared. Okay, so all I did was just decompose my vectors in terms of each of those vectors here. So now I have 4 vectors, so now I have 4 terms. Now, we also have another system to the side over here. So I'm going to call this going to be our tension is pulling down, is going to be gravity. So it's going to be M2G. And so we're going to have a tension force pulling this up. Now, this tension force is equal to this gravitational force, and so these tensions are going to be the same. So therefore, this tension is actually going to be this gravity. But I'm not going to worry about that right now. I'm just going to decompose the vectors in terms of the components. And right now, I'm going to do this as my standard basis vector, but later on, I'm going to rotate the frame to make it easier. Okay? Says, bro, I'm cooked. Guys, this is one of the hardest problems that you're going to see, okay? If you can get this, then you're not cooked. If you get this, you're not cooked because this is one of the hardest problems. So let's keep it going here. So let's say I give you the mass of this guy here. Let's say I give you the mass of M1 here. Now let's decompose our vectors. Now we have to do some thinking. Everything up to this point was no math. Everything up to this point was no math. Okay, now we got to do some thinking, guys. And now I'm going to say I'm going to decompose it into my X and my Y here. So this is what I mean by decompose. You're literally going to not even think about it. You're going to say everything for your X components on the left-hand side, and then everything for your Y components on the right-hand side. So what do I mean by that? I'm just going to rewrite the entire thing in terms of X and Y. Okay, and so for my X components, I'm going to basically say my gravity in the X direction, my gravity in the X direction, plus my tension in the X direction, plus my normal force in the X direction, plus my friction in the X direction. Okay, great. Now we have to do some thinking here, right? Orthogonality type. Now for my Y components, same thing here, right? GY plus TY plus NY plus FY here, right? So now let's see our GY. Well, our G, we don't have anything in the X, so I'm going to cancel out my G. Okay, so my G is only pointing straight down, so I got rid of my G here term. Okay, I got rid of my G term here. All right, now I have to decompose my T. All right, now my T is a little bit tricky here, but do you see this invisible triangle? This is a big old triangle like this. Okay, but I see another invisible triangle like this here. So if I want my X component, guys, is this going to be my cosine of theta or my sine of theta? Let me draw this out in case people can't see that visually here. So let me draw my tension real quick one more time. And then if I have a triangle like this, and then my tension is effectively making another baby triangle that looks like this. This is basically what my tension looks like. So if this is my theta here, if this is my theta, then this theta must be the same here. And so if this is my Tx and this is my Ty, is my Tx in terms of cosine or sine? So remember, guys, SOHCAHTOA, is my Tx in terms of cosine or sine? Okay, SOHCAHTOA. Okay, so my Tx going to be in terms of cosine or sine? For my Tx, Marlon says sine. Gabriel says sine. I agree with Moonlight. Okay, I'm gonna say cosine, guys, because SOHCAHTOA. So this is my adjacent side. So I'm gonna say my Tx here. My Tx is T cosine of theta here, right? And my Ty is T sine of theta. Okay, does everyone understand how I did that here? Okay, good job, Sophia. Good job here. There you guys. Good job. Okay, so I'm gonna decompose my Tx here is a T cosine of theta here. Okay, and then here we go. Now I have my normal force here in the x direction here. All right, but now my normal force in the x direction is opposite to my gravity here. So I got to do a similar triangle here. So I got to lock in for this triangle. So now that was my T triangle. I got to lock in for my gravity triangle so I can get my tension triangle. All right, so this part always confused me in high school. This part always confused me. But then one day my friend said, bro, this angle theta is not this angle here. So a lot of people, including myself, I was confused because I thought this theta was this theta. But that's not right, guys. This angle, where's this my theta here? My theta is right over here, guys. So this is my angle theta on this tension here. So now this is theta here. So now if I want the normal force, that's going to be my positive mg here. And now do I want the cosine or the sine? Now do I want the cosine or the sine here? I'm not passing. No, come on, Gabriel, you got this. Don't give up. Don't give up, twin. Never back down, never what, guys? Never back down, never what? Put down in the chat. Never back down, never what? Okay, Marlon says sine. Okay, guys, this time we're going to do, let's draw this other triangle here. Okay, now we have to decompose this other triangle. Okay. Think about SOHCAHTOA, twin. Think about SOHCAHTOA. So now I'm going to say that this one is this side here. So if this is my mg, if this is my gravity here, okay, if this is my mg, and then I want the cosine side, and I want the adjacent side. So cosine is adjacent. So adjacent is what I wanted here. I know it's hard to visualize, so let me try to paint it here so you guys can see it. This is my adjacent side, so that's what I want. And so my cosine is adjacent, which I'm going to call my mg in the y direction. Okay, that's my mg in the y direction, which is what I wanted, divided by my hypotenuse, which is my mg in the x direction. So this is what my mg in the y direction, which I'm going to call my tension y. So my tension and the y was that one. So guys, I apologize. I meant to say the one in the x direction. So I meant to say this one here. So I want this one. So that's going to be basically my tension in the x direction here. Not my tension, guys. I'm getting cooked. I meant to say my normal force in the x direction. There we go. So this is my normal force. So if I use my sine now, if I say my sine was my opposite, that was my tension in the y direction, that's going to be Ty equals mg sine of theta, okay? Guys, you're not going to get it right away. You're not going to get it right away. If you're thinking that you're cooked, guys, don't be scared. If you're thinking that you're cooked, don't be scared. You're not going to get it just by watching a TikTok live stream one time. You need to practice this. You need to practice this multiple times, and then you're going to see it. So I'm going to put this as a negative mg sine of theta. I'm going to do this as a negative mg sine of theta because, again, I wanted my opposite side in the negative direction here, okay? Okay, so now I have this force here and this force here. Now all I need to do is add my normal force here. That was my normal force. All I need to do is my friction force here. But my friction is just my normal force. So I'm just going to say that's minus n, which I already said was minus mg sine of theta. And that's equal to 0. So guys, this is my first equation. We are almost done here. Believe it or not, we are almost done. I know it looks confusing. I know it looks scary, but this is not going to be the first time you're going to see this. So make sure you lock in here, okay? You're not going to get physics in one day. You need to practice multiple times and then you'll see it, okay? So guys, this is our first equation here. And so I got T cosine of theta, which represents my tension in the right here. And then I got minus mg sine of theta, which represents my x component of my normal force. And then my friction force is just mu times that. So if I want, I can factor out. If I want to factor out my mg sine of theta, I can. So I'm just going to factor out that because that's going to be T cosine of theta minus. Okay, I'm going to factor out an mg sine of theta. And I'm going to say 1 minus mu. I'm going to say 1 minus mu k. So usually mu will be between 0 and 1. So mu k is usually between 0 and 1. So your professor will say, oh, it's going to be 0.4. Oh, it's going to be 0.7. So that's going to be like our constant. That's our friction coefficient. Okay, and then we can solve that for tension. But again, we already said that tension was M2G. So if I want to plug in tension here for M2G, I can do that here. Great, guys, we're almost done. Exactly, you're kind of making your own equation, okay? You're kind of making your own equation, but you're solving this in terms of Newton's second law, guys. Isn't that crazy? We're doing all this math which only came from Newton's second law. All right, guys, now we're going to do the y component. So we're going to do the exact same thing. So I know my g in the y direction is this one coming down. So I know my g in the y direction is this one coming down. So I'm going to say that's negative mg. All right, so now I got to do the tension in the y direction. So tension in the y direction, I got to say, remember, we already said that tension in the y direction is t sine theta. So I'm going to plug in tension in the y direction is a t sine theta. So it's going to be a t times the sine of theta. And guys, I promise I'm going to post this video. I usually don't post my live streams, but I got so many requests to post this one. I'm going to post this one today here. Guys, physics is hard because this is calculus, this is geometry, this is math, this is algebra. You're doing so many classes at the same time, twins. So if you don't get this right away, it's totally fine here. Okay, and then ny, what is ny going to be? Ny, we already said that one too. That was going to be that's going to be our adjacent component. Okay, so that's going to be our adjacent component. That's going to be mg cosine of theta. And it's going to be positive this time, mg cosine of theta. And I already said that mu was our friction force, and this is going to be set equal to 0. And guys, we're pretty much done. That's all we can do here because we don't have any numbers. So let's write our final answer nice and cleanly. So our final answer are these two sets of equations, 2 cosine of theta minus mg sine of theta times 1 minus mu sub k is equal to 0. That's equation number 1. And then minus mg plus t sine of theta, okay, plus mg cosine of theta. Okay, if I want, I can factor out that mg cosine of theta again as a 1 plus mu equals 0. That's going to be equation 2. We also have our third equation, which says that tension is equal to m2g. So guys, this system of equations is our answer. Okay, I know it doesn't look like an answer because we don't have any numbers, but that's the point. We don't need any numbers. We can solve for that depending on what your professor says. Okay. Yeah, this is kind of like an outward problem because we basically have a box on a plane simultaneously with a friction force pulling that down here. Guys, this was the objective. The objective was to solve the system. So this was case 3. The objective was to quote unquote solve the system. Solve the system just simply means what are my equations and what are my unknowns, okay? I know it looks complicated because we don't have any numbers here, but that's basically done here, okay? That's basically done, okay? So guys, if you want your own questions solved, just go onto the website or into the Discord and then submit your questions here, okay? Just go to engineeringminds.co. That's where we can actually do your practice problems for free, guys, okay? I try to draw them. I try to solve the problems every single day. And guys, I promise I'm going to upload this live stream up on my YouTube channel. So make sure you follow me on TikTok and YouTube to see the live stream after this. And guys, I'm super excited about the explore resources section here because this is where we're going to see all the practice problems for chemistry and physics. So take a look at it right now because right now we only have one problem for physics. Okay, but guys, give me like 1 week and then this is going to be totally filled out with like so many problems for us to see and visualize. Okay, guys, I know this is like really tricky, really confusing, but give it some time. Just practice it every single day and it's going to make sense over time. Okay, it's going to make sense over time. You just have to practice it a lot. Okay, this is the general procedure and that's basically how you solve any physics problem, guys. Is this helpful or making it worse? Is this helpful or am I making it more confusing for people? Let me know, guys, okay? Jared says want chemistry. Bro, Jared, you missed it. We were doing chemistry. Of course, Marlon. Can tension be negative? Yes. The absolute value of tension cannot be negative, but the direction in which tension is pointing can be negative. Okay, because tension is a vector, so the value of tension cannot be negative. The value of tension is always going to be positive. Okay, so but the direction can be negative here. All All right. DBS says, can you do circular motion? Guys, I have to do the Q&A section here. So I have to go ahead and check the Discord here because I promised that at 7 o'clock we were going to do the Q&A section here. So if I don't see any questions, then I'm going to answer whatever questions we have here. And guys, if you want to join the Discord, let me know here. All right, guys. And then I don't see any questions here. So basically, what should we do next, guys? Should we do more examples for physics, or should we do what? What should we do here? Should we do more examples for physics, or should we do ones with numbers or circular motion? So I think I saw some for circular motion, and then I saw some for E and M. So I think what I'm going to do is I'm going to hide this for a sec, and we're going to do another quick poll. I'm going to ask, what's the next topic? If you're going to vote, if you want circular motion, let me know if you want circular motion. And then if you want E and M, you're going to vote for E and M, guys. Okay, so got 60 seconds on the clock. So here's the poll. Okay, you got about 10 more seconds to think about it as I pull up this poll. All right, guys, so what's the next topic going to be? Is it going to be circular motion or electricity and magnetism? And then this is going to be our last couple of topics for today. So if you want electricity and magnetism, vote for, let's see, if you want circular motion, you're going to vote for happy face. If you want electricity and magnetism, you're going to vote for crying emoji. Okay, so guys, if you want to do E and M, switch gears here to a different topic. E and M here, vote for crying emoji. If you want to do circular motion, vote for happy face. What was that question I missed? Join the Discord at the link in bio, twin. Why do people use down as negative for pulley questions, but up in free body diagrams as positive? I personally always do down as negative. But you can make up as positive if it's going up. Guys, it's really close. We got 6 for circular and 4 for E and M, guys. So 10 more seconds left. I can't believe you're brought to vote for such gross topics. Jared, where were you when we were doing Gen Chem earlier, bro? Skate Ninja says no electric. Guys, unfortunately, we got 6 for circular and 5 for crying, 5 for E and... No, yeah, 6 for circular and 5 for E and M. So, guys, if you want me to do an E and M tomorrow, make sure you hit that follow and then join in tomorrow's live stream, guys. So, I'm sorry if you did not get E and M. And, guys, we're going to do circular motion for one more session today, and then tomorrow, make sure you vote in tomorrow to see that. Or you can, again, join the Discord, and then I can answer your questions in the Discord, or submit a question up on the website, engineeringminds.co. Make sure you check the website questions as well. Oh my gosh, I missed the website questions. Guys, I need to check some website questions real quick. Guys, give me 1 sec. I think I got some website questions. Guys, we might not even have time for a circular. Twin. We got to check the website. Thank you, Jackson. Yeah, just join the Discord, and then we can go over circular and EM in the Discord here, guys. But I got to check the website here, guys. Whoops. All right, guys, give me 1 sec as I pull up these. Okay, guys, give me 1 sec. My laptop is getting cooked here, but here we go. All right. So, okay, I'm going to open up these website questions. I did down as negative for a pulley question, but when I added friction, it messed it all up. I did down as negative for a pulley question, but when I added friction, it messed it all up. Friction had to be going away. Make sure friction is always going away in the direction, away from the direction of motion, twin. So which direction did you say your friction was? Twin, can you, Aziz, can you DM me your problem either on TikTok or on the Discord, okay? Or on the TikTok Q&A. I can't post the link here, twin, but you can join. DM me if it didn't work. If it didn't work, that means I don't know. If it didn't let you work, I can't post the link here, twin, because it's not gonna let me. So just DM me for the link, twin, and then I'll send you the link. Okay, guys, so I'm gonna do the first question here. You can get there on the link in bio. Go to the link in my bio or engineeringminds.co. And then this is how you join the Discord here. Guys, you're in luck. Whoever voted E&M, we got an E&M problem. Whoever voted E&M, we got an E&M problem. And then Nadia for chemistry as well. So, but Nadia, wait, you already asked that. Okay, that was last week. Nadia, did you get that answer? If you're still here, let me know because I think I responded to you. So hopefully you got that because I remember you asked me that. Okay, so guys, whoever voted E&M, you guys are in luck because the first question is actually an E&M question here. Okay, so the first question is E&M. Okay, thank you, Nadia. All right, so guys, we are actually whoever voted for E&M, you guys are in luck because we actually got an E&M question. So I apologize for the people that voted for circular motion because we're gonna do this, but then I'll try to do circular motion as well, guys. So whoever voted for circular motion, I mean E&M, you guys are in luck because we actually got an E&M question submitted. Okay, so I'm gonna go ahead and send this to myself and drop it in the Discord. And here we go. I'm gonna drop this in physics. Okay, guys, so I may or may not be able to get this on the first try, so let's try it out together and let's see how we do this together here, okay? So this seems like it's gonna be a Gauss's law question. Okay, and it seems like, let's see, all right, so I'm better at helping people their homework than you. Sure. That's fine. That's cool. And so here we go. All right, here we go. So now we have this question. All right, a thin, flat, non-conducting disk with radius r naught and charge q has a hole with radius r naught over 2 in its center. Find the electric potential V at points along the symmetry x axis of the disk aligned perpendicular to the disk passing through its center. Let V equals 0 and x equals infinity. All right, guys, so here's our question. Let's make this bigger because it seems hard to read. Guys, can you read that or is that still too small? Let me know if you guys can read that. Okay. So a thin, flat, non-conducting disk with radius r naught and charge q. Can you guys read that? So a disk with radius r naught has a hole with radius r naught over 2. So this is r naught over 2, and then this is going to be r naught. And so disk is a cylinder, so we're going to do cylindrical geometry. And then I'm going to color this in. And it wants to get the electric potential. It's on the screen, guys, yeah. Okay, so this is our annulus, this is our cylinder. And then if you're the person that dropped this question in, let us know so we can see out, we can figure out what parts you're confused on. If this was you that submitted this, let us know so we can figure out what parts you're confused on. All right, guys, so let's see if we can lock in for this problem and solve it together. So, All right, so we have this ring here, and it has a charge Q. So this is producing charge, and we need to find the electric potential Vx at points along the symmetry x-axis of the disk, a line perpendicular to the disk. So I'm gonna draw a line like this going through. Okay, so this is my x-axis here, and cool. So what I'm gonna do here is basically like I want to find the volume. Okay, first I want to find the volume of this cylinder real quick. Okay, I want to lock in for the volume of the cylinder, which is basically area times height, which is going to be basically R. There's no, let's see, there's no height here given. Okay, and I'm going to do pi r squared minus r squared over 2. So that's basically the volume here, but I don't see a height. So really this is just going to be the area is pi times r squared minus r squared over 2. Okay, I just submitted a question. Okay, got you. I got you. All right. All right, guys. So now, all right, now what we're going to do is basically we're basically going to use Coulomb's law. Okay, so we're going to use Coulomb's law. So I'm not going to solve the entire thing per se, but I'm just going to start from scratch here and then say that the electric potential V, okay, I'm going to say that the electric potential V is going to be 1 over 4 pi epsilon naught times Q over R, okay? Which I do have my R here. I'm trying to brain rot. Welcome into Gauss's theorem. And let's see here. All right. And I also want my charge density here. So I'm going to say my charge density. I want my charge density, let's say rho in terms of the area. This is a 2D system, guys. This is not 3D. So let me just get rid of some of these. Okay, this is just a ring. This is not an actual annulus. This is just a ring. So let me just erase some of that. Okay, and then this is my first one is R naught. Okay. And I'm going to say my charge density is basically Q per area. Q per area, or that can essentially be dq dA. So if I know my dq, that's going to be rho times dA, but really that rho is going to be a sigma because this is a 2D question. Sigma times dA. And guys, I have to log in for a sec. My area is going to be 2 pi r dr. 2 pi r dr. So I'm going to say my dq is sigma times 2 pi r times dr. All right. Cool. Okay, now we got to do some geometry here for this distance x here. Okay, so let me just do another triangle here. So what I'm going to do is basically this distance from the ring. And I want this hypotenuse. I'm going to call this L. And this is going to be, this is basically going to be R. I'm going to call this distance L. This is going to be R naught here. But that's actually going to change. So I'm going to call this X. I'm going to call this X. And this is going to be, what would this R be? What would this height be? This is going to be R, and then this is going to be an X. So I'm going to call this, I'm going to call this R. I'm going to call this R and this X. Okay, I'm going to call this R and this X. Okay, so then Pythagorean theorem gives us L squared equals X squared plus R squared. And I want L, so I'm going to take the square root of both sides. I'm going to do X squared plus R squared. All right, cool. All right. So then I'm going to go back to my Coulomb's law here. What do I have here? I have basically this as dV. I'm going to change this to a dV here. dV equals 1 over 4 pi epsilon times dq over r. This is the distance L. So I'm going to change this to an L. And so I'm going to go back here. I'm going to say that this is dV equals 1 over 4 pi epsilon naught times 1 over square root of x squared plus r squared dq. My dV can be rewritten in terms of my area. Okay, if I do dV here, I'm gonna do dl. Here we go, dl. That's gonna be dr basically. dr times 2 pi r dr times sigma. Yay! Okay, guys. I wrote the equation, but I kind of don't want to solve it. So this is the equation, but I gotta lock in for this calculus here. So I kind of don't want to solve it though, because we're gonna need some nasty calculus here. So I'm gonna leave it at that. I'm gonna say that this is the solution here. So who was that? Unless you really want me to solve it, but I'd rather just move on. There's a calculus. This is Matthew. Blessing Matthew. If you're here, let me know. Blessing Matthew. If you're here, let me know, because this is the solution here. And then we have to solve this mathematically here. If you're here, let us know. If not, speak now. If not, speak now, forever hold your peace. If not, we're going to move on, because this is going to be nasty here. We have an RDR with a 1 over square root x squared plus r squared. Oh, okay, it is you. Oh, snap, it is you. Okay. All right, were you understanding up to this point? Were you understanding how I got this for Coulomb's law? Were you understanding how I got this for Coulomb's law? Let me just get you started on the integral. Let me just get you started on the integral. James says you can't do that. There is no right triangle indicator. James says you can't do that. There is no right triangle indicator. I'm not sure I understand. I'm afraid I disagree, because we have the distance that we want from R to X. So that's going to be based on this point here. It's fine. Okay, sounds good. Thank you. Appreciate you. So hopefully this was helpful anyway. That's kind of what you would do, and then you would solve this integral. And then basically just note, last thing I'm going to say is you're going to have your dr here, r here, R here, dr here, and then R here. So do everything in terms of R. Your dq is just going to be a q. So your dq is just going to be a q. All right. Yeah, E is Z is your next. Okay, E is Z is next. Okay. Mohammed says, can you do related rates? Mohammed says, can you do related rates? Do you upload these notes anywhere? Yes, I'm gonna upload this to the Discord here. Okay, I'm gonna upload this to the Discord, and then I'm gonna. I promise I'll upload this on my YouTube channel, the whole live stream, if it lets me. If it lets me, I will. If it doesn't let me, then we'll figure that out. Okay, so E is E says, why does my acceleration come out good using right positive and down negative, but when I add friction, it doesn't come out right? So I'm gonna download your question. And then, guys, this is gonna be my last problem. And then I gotta head out, guys. This is gonna be my last problem. I'm gonna end it for today, but don't worry, I will be back tomorrow. And then I'm gonna send this to myself just in case that you're trolling here. I'm gonna send this to myself privately, just in case. I want to make sure that this is not anything bad. And then I'll double check. Okay. No, we're good. All right. So I'm gonna pull this up. Send this to myself here. I'm gonna drop this in. But this was your own handwriting, so I'm gonna just send it to myself anyway, just in case you didn't want to share that. Ali's question is also there as well. So I see Ali's question there as well. So if Ali's still here, I'll do that as well. And I think I'm getting the hang of like how we're doing these live streams. Like it's pretty much the first hour is like, like the first hour is kind of like an easier topic. The second hour is like a medium topic, and then the last hour is like Q&A. That's kind of what I did today, and I kind of like how I did that. I'm live not every single day, but I go Monday through Thursday, so I skip Fridays and weekends because sometimes I do stuff on the weekends, guys. Okay, so here's gonna be the next problem. So Monday through Thursday is my live stream schedule, and then I gotta upload my live stream schedule on the website as well. All right, Aziz got this here, and so they said when will be up, down, or negative, positive. So 5 o'clock PST, that's 8 o'clock EST. 5 o'clock PST, 8 o'clock EST. I definitely understand the confusion. I remember definitely getting confused about this in undergrad. So why does my acceleration come out good using right as positive and down as negative, but when I add friction, it doesn't come out right? I definitely understand the confusion because I remember getting confused about that as well. So let's break this down carefully one by one. So cool, and I appreciate you uploading the notes. It's definitely gonna help. Okay. All right, so we got to analyze this system here. And I see why you asked this, because you're like, oh, a pulley problem. Let me ask a pulley question. So we have this 10 kilogram going here and then 20 kilograms. So we know, all right, so right off the bat, this is the key here. Which one is heavier, right? This one's mass 1. Oops, that was way too big. This is 10 kilograms and this is 20 kilograms. So we know that if 20 is heavier, then the direction of acceleration is going to be to the right. So the direction of acceleration is going to be to the right. That's the key here, right off the bat. Let me just write that down. Because m2 is greater than m1, so therefore acceleration is going to be negative gravity in the j-hat direction, meaning our acceleration is going to be going down for m2 and then going to the right for m1. So that's going to be my first tip for you, is make sure you see which direction is heavier and which direction is pulling that down, right? Okay, and so now let's see what you're asking here. So you're saying, okay, when I add friction, so first you said do it without friction. So I'm assuming everything here was without friction, right? So you said F net is M1 plus M2 times A. A is F net divided by M1 plus M2. The weight was 196 here. That's 20 times 9.8, that's 196, good. And then the summation of all forces in the y direction is basically, okay, tension minus mg. So you said m2a, good, equals tension minus m2g, solid. You're crushing it here. Fx equals the tension, good, and then tension is just going to be the same. Now this tension is m2, by the way. Okay, this tension is going to be, let me see here. So the summation of all forces in the x direction is going to be m1a, and that's equal to tension. Okay. Never mind, I take it back. That's going to be m1a. Good job. All right, good job. So we have tension is here, but then this tension is also the same as this one here. So that's going to be, okay, that one here. All right, so I'm assuming you solved this correctly. Okay, so you got A equals 6.53 meters per second squared. Good. So I'm assuming you got this, so I'm gonna just skip this part because you're not asking about that. But then you're saying, all right, now we're gonna do it with friction. Now we're gonna do it with friction. I noticed you didn't draw your FBD twin. I noticed you didn't draw your FBD twin, so let's draw our FBD, which means that we have to draw out our boxes with our forces. Okay, so that's going to help to clarify a little bit of confusion. So this one's M2, this one's gravity, this one's the normal force pointing up, this one's the tension pulling to the right, and I have to draw my friction force going here. Okay, so I noticed that you didn't draw your normal force is coming up here, nor your friction force coming over here. Let's see if that changes anything here. So we have mu sub k is given, the normal force is gravity here. Don't forget gravity. Okay, it's going upwards, that's fine. Oh, we also have static friction as well. So we're going to have to do a little bit of static friction calculations as well. Can you factor out that negative in that part? Can you factor out that negative in that part? Oh, in part one? I'm sorry, twin, I missed that. Okay, so you were asking about this? Can you factor out that negative in that part? So M2A, good, equals M1A minus M2G, good. Yeah, you can factor out that negative here. Yeah, that's fine. You can factor out that negative here. Yeah, mathematically that's correct. So M1A minus M2A equals minus M2G. Yeah, you didn't factor it, you basically subtracted it, but then you factored over here. Yeah, that's fine. So A M1 minus M2, that's fine as well. You're doing great. Your math skills are pretty solid here. So yeah, again, I'm going to move forward because I'm pretty sure you got that right here. Okay, but then down over here, now you're saying, all right, now when I did it with friction, something's wrong here. So now with friction, so now here's where some confusion is occurring because you wrote out F net, but is this F net in the X direction or the Y direction? Okay, so that's tension going right, that's Fk is going left, so I think this is the X direction. All right, that's fine as well. Plus the tension minus the 196. So this one was, what is this one here? I'm not sure what is that one here. And all right, just moving forward here. M1A minus M2A equals T minus Fk. Okay, I'm assuming that's right here. So let me review your question one more time. So why does my acceleration come out good using right as positive and down as negative, but when I add friction it doesn't come out right? Okay, I understand the question. Yes, it's time for open session, but make sure you drop in your questions quickly because I'm gonna end it soon, guys. I tried to do Fnet for Y and X. That's what my T... I tried to do Fnet for Y and X. That's what my T minus 186. Hey, Derry. Okay. Garcia Dog says, can you show the whole problem? Maybe I'll just answer the whole problem with friction. Ooh, good job, Derry, good job. You're gonna crush it though. Would you recommend AA or AS? They say AA is easier to transfer credits. What is AA and AS, twin? Associates, and what is AS, twin? So do I find F net only in the X direction because that's where friction is going? Well, good question. Okay, so let's do it in the... We might need it for the Y as well. Oh, if you want to do STEM, twin, what's your major gonna be? If you want to do STEM, make sure you do AS. If you want to do humanities, you can do AA or AS. But if you want to switch to like STEM, medicine, engineering, make sure you do your AS, twin. Yeah, Theory says look at the specific program. Okay, let's just solve it because I'm not really sure I'm understanding your question. So I'm gonna solve it and let's see at what point the confusion lies. Okay, I'm gonna solve it and let's see at what point the confusion lies. So I'm gonna do the same process that I did earlier here. Yeah, this is E's question. Okay, this is E's question. I did W minus T, which I didn't understand. That is correct. Okay, so let's start with weight here. That is W minus T. So W minus T. Okay, actually not tension. We're gonna do gravity here is pointing down, so that's negative mg. So I'm going to say negative mg plus mg equals 0. So there's no change in the y direction. So pretty much we're done with the x. So yeah, the reason that was a good way of putting it. Let me go back to what you said. That was a good way of putting it, E. You said I only find F net only in the x direction because that's where friction is going. That's pretty much correct. I only need to find F in the x direction because that's where friction is going. So now that was only for y. So now let's do it for x. So for x, I basically see I have tension going to the right and then friction going to the left. So let's do tension to the right. So tension to the right is a positive x. And then I'm going to say friction to the left is negative here. So that's going to be F sub x. Okay, and I'm going to set that equal to my mass times acceleration. I'm going to set that equal to my mass of 1 times my acceleration in the x direction. But I know that my tension is equal to my normal force of my equal and opposite reaction force for my m2g. So my tension is actually an m2g, okay? And then I'm going to replace that with fx. But I also know that my fx is a mu sub k times the normal force, which is m1g, and that's equal to m1a times x. Okay, so this is my equation for equation 2. So let me know if your signs match up here. Let me know if your signs match up here. So I said that my tension is m2g, and then minus mu sub k m1g. Now, the thing is we have static friction and kinetic friction. The thing is we have static friction and kinetic friction. I'm not going to lie, twin. I'm blinking out on the static part. So what is our static part here? This is 0.4 and then 0.2. So you said static was 0.4 times 9.8. Or what is that? Times 18. What is this? Times 10. What is this static part? Twin, I'm not going to lie, I'm blanking out on the static part. I'm going to skip the static part for now. I'm just going to leave it as an open question for now. But let me continue forward so I can see your sign confusion here. So regarding the sign confusion, notice that, again, my tension is going right. So I define my x to the right as positive. This is positive x. And then my x to the left as negative. Does that clarify your confusion here? On the right hand side, that's positive x. On the left hand side, I have negative x. The question was asking if static was smaller or bigger. I see. Yes, mu sub k mg is the normal force. Correct. Mu sub k is the normal force because I have an equation for friction, which says that friction is equal to mu sub k times the normal force. Exactly. Okay. And if the force was more than static, then would the force be with kinetic friction? Got it. So what we're gonna do is first we're gonna plug in our mu sub k for static, and then we're gonna plug in mu sub k for kinetic. So first, I'm gonna set this as mu sub k is equal to 0.2, and then mu sub s is equal to 0.4. And then we know our m1 is a 10, so I know this, and I know my gravity. I know this is 10, and then my acceleration here. So what I'm gonna do here is solve for my acceleration from this equation, and then by we I mean u. We're gonna say that m2g is gonna be minus mu sub k m1g is equal to m1a sub x. Okay, if we did this correctly, we should get a positive answer here, twin. We should get a positive acceleration. So just for a sanity check, let's put all these numbers in. First, I'm going to do mu sub k equals, so 20 is a constant, m equals 20 is a constant, m1 equals 10 kilograms, that's another constant, and then g is also a constant, so it's going to be 9.8 meters per second squared. And then first, I'm gonna let mu sub k equal to, what was the kinetic one again? It was 0.2. I'm gonna do 0.2. So I'm gonna do ax for mu sub k equals 0.2 for mu sub k. And then I'm gonna let mu sub s equals 0.4 for mu sub s. So this is gonna be for kinetic, and this one's gonna be for static. So first let's calculate for static, and we're going to do it again for kinetic. So for static, I'm going to do m2g. So I'm going to do m2g minus, so m2g is a 20 times the 9.8 minus m2g minus, okay? No, you don't have to use the y direction. Yeah, that's right. You don't need to use y because we get 0 equals 0. Don't worry about the y. So then I do minus mu sub k is a 0.2. 0.2 times, was that m1, which was a 10, which is a 10 times 9.8 divided by, I think it was m1. So I got 10 divided by 10. So I got 17.64 for the mu sub k. 17.64 meters per second squared for the mu sub k. And then for static, I'm going to change that to a 0.4 from a 0.2. So for my 0.4, okay, I'm going to get 15.68. I'm going to get 15.68. So here we go, twin. This is how I got positive numbers for acceleration. Now, do be careful with the problem statement. Carefully identify which one is the correct one here, because I need to see which one is correct. Is it static or kinetic? So make sure you read the problem statement, and I got positives for both here. Okay. Unfortunately, I didn't get enough votes for Orgo, but make sure you join in tomorrow around the same time, 5:30 PST or 8:30 EST if you want to do Orgo tomorrow, twin. I only got questions for physics today. It was kind of weird. I was like, where's the Orgo people? Then set T as the friction force. So T is not going to be the friction force. T is going to be the downward force of gravity, twin, because M2 is our tension force. It's not kinetic acceleration, it's kinetic friction. So should I use downward as positive or negative for pulley questions? I personally just use always down as negative. I don't change my down. I always make down negative. The only thing that I change is the horizontal. So let's make this, let's do like this. Down, gravity, always negative. Down, gravity, always negative. Always negative. Is always down, always negative, down. And then my y vertical is always positive. Okay, but for horizontal, if it's accelerating to the right, then I make my AX right positive. But if it's accelerating to the left, I make it AX is going left, then I make it negative. So I always make my down negative. I know some professors say whatever direction it's going, make that positive. I always make my G negative. The only thing that I change is my horizontal. So if A is going to the right, make that positive. If A is going to the left, make it negative. But I personally always make my G down negative. If you want to change it depending on the acceleration in the y direction, that's fine too. I personally do not recommend that because that will change whether the acceleration is going up or down. You can get T from gravity and it's the same. You can get T from gravity and it's the same. T from gravity, it's the same. Yeah, sure. The dude in the vid had an equation like this. F net equals W. F net. Let's write that down. F net. Can you send me the video, twin? Can you send me that video they're talking about? I want to see what it is. F net equals W minus the force of kinetic friction. The force of kinetic friction. So that's going to be gravity. That's going to be gravity minus the... Yeah, because that's going to be this equation. He did the y one, but that's going to be equal to 0. That's going to be... Oh, that was organic chem tutor? IDK, why he did that? So the static and friction, static and kinetic friction, tension, normal force, inclined plane, pulley system problem. Okay. Then I'll just look into it because like I don't know, twin. I'm not sure what he did. I have to like watch the video. So, but that's my suggestion for you. 2 hours? Oh my god. I definitely gotta watch that. You gotta lock in for that one. Okay, I took a screenshot of the vid title, so I gotta check that out. But yeah, that's gonna be the general procedure, guys. So W would be the mg from the bottom box, correct? Minus mg equals T and the x friction force. Okay, that also seems correct. Okay, but did that help though? Did that help clarify that if you're going to the right, just make that positive here? Okay, if you're going to the right, you're gonna make that positive here. I'm curious how you got to this point. It can't be that hard, right? At 2 hours and 6 minutes. Okay, so try it again. Try to see if you can replicate what I did from scratch. Okay, you can either take a screenshot of this or I'm gonna drop it in the Discord. How I got to this part, I'm assuming that you mean like, doing like STEM and tutoring. So I basically, real quick, guys, I'm gonna talk about that real quick. So yes, I'm gonna address you. So why do some people make down positive? Because they want to make their lives easier for making the down positive if it's going that way, which is fine. I'm not going to judge them. I personally just don't want to change my positive and negative. I just want to make positive up. So to each their own. It's totally preference here. Okay, guys, so the Discord is in link in bio. Pretty much gonna end it here, guys. Pretty much gonna end it here. I'm gonna work on trying to upload this live on my YouTube channel because I got a lot of requests. It's gonna be a long process, so let's see if that even works. Absolutely, I do chemistry. So guys, here's all my information. Just go to engineeringminds.co. This is where you can see all the information. I got private tutoring available, group tutoring for OChem. I got physics available. I got practice problems. The Discord is here as well, guys. This is everything that you need to engineer your mind, guys. I go live every single week, Monday through Thursday, right here on TikTok and Instagram. And if you go to the website, engineeringminds.co, this is where you're going to find all the resources you're going to need for math, chemistry, and physics. You can comment down in the TikTok Q&A what topics you want me to go over in the next live. I'm going to take preference here. So if you want me to go over a topic, make sure you tap this TikTok Q&A section here. Okay, and then that way I'll know what to go over tomorrow here. Okay, guys, I'm pretty much going to end it here now. I'm sorry, Roshan. I'm sorry. I'm going to end it here. But I do have vectors TikToks, bro. I do have vectors here on TikToks. Just look up my name on TikTok and then put vectors, bro. I already have a lot of vectors problems here. Okay, guys, last but not least, if you need tutoring, don't wait to sign up. You can sign up for a free consultation call by clicking the link that says book tutoring. Guys, I've been helping over 25 students lock in for classes like Gen Chem, Organic Chem, Physics, Calculus. I just got 2 new clients this week for Physics. I got first year Physics. I got calculus based Physics. I can help you out with your AP Chem and Gen Chem in high school and college. Good luck, Roshan. Good luck, Janet. Good luck, everyone. Thank you so much for joining. Thank you so much for joining. Pretty much going to end it here, but I will be back tomorrow at 5:30 PST, 8:30 EST. Thank you, Jackson. Thank you, Hule Academy. Shouts out Hule Academy for helping me build the website. Guys, I'm super excited about the Explore Resources page, so stay tuned for this one here. This is going to have every single problem I've ever done. I got to lock in. I got to input the problems. I've solved the problems, but I've had nowhere to put them. Now I finally have a place where to put all the problems, and that's why I'm super excited about this website here, guys. Right now, I only have 8 problems for Chem, but you can learn about vapor pressure, calorimetry, Lewis structures, and constitutional isomers. So stay tuned as I build this out with you guys, chat. Okay, guys, thank you so much for joining. Pretty much going to be here. AJ, separations. I can't wait to add separations as well. I can definitely help you out with separations, bro, if you're taking it right now. All right, guys, pretty much going to end it here. Thanks so much again, and peace out, my friends. I will be back tomorrow.